Files where it shouldn't be there. Hi everyone, welcome to the Moon Day organized by Neurospace. We are very happy to see you all. Sorry for starting a bit late. We had some technical problems, but now we are all set to have a great Moon Day ahead of us. So today our first speaker is Irene Selvanathan. She's co-founder and CEO of Neurospace. And we also had a second speaker, Lennart Fox, who both will be presenting to us today about Neurospace and how they decided to start it, what their roles are in the company. So first we will start with Irene, who will briefly tell us about her passion for space and why it's so important to explore Moon for further space exploration. And then we will move on to learn more about Lennart and his work at Neurospace. So please, Irene.
So hello, welcome, and yeah, I apologize for the delay. We had some issues to fix, but yes, we just started, and we hope we will enjoy the day. We have wonderful presenters. We have the rovers on the yard. There we are on #TheMoon. This is how it's called in Rostock Lager. And this has been presented also by the Planetary Transportation System. So we want to thank them as well to having us here. And thank you to the Moon Village Association, of course, for being letting us be one of the events for the International Moon Day today. So about us, we are Neurospace. We are a startup based in Germany, and we were founded 2020. And well, we started with different topics at that time, and then it came up that we were thinking of going into other directions, and then we were starting to focus on the moon. So we were thinking at that time what's going on the moon. We found a lot of interesting things, the political stuff, and as well as the whole technology, which made it very fascinating. And what we also found very interesting was that industry is more and more coming up, and the importance of moon. So we actually wanted to design some technologies based on communication, but then realized that in Europe there is a huge lack. Unfortunately, there is not so much interest in space exploration, especially in direction to the moon. So we had to go even more complicated way. We first of all started to develop a rover, and then facing on what's going on, because we have to participate. And that's the reason why we have designed our rovers, which we call HiveR. We wanted to extend them, make them work as a hive, as the name is called, and build them up as swarm technology. That's why they are small. They're based on CubeSat technologies, and this is because most of the engineers at Neurospace already worked for new space technology, especially CubeSat technologies. This is where we come from originally. And going into different direction, especially from Europe, is actually really great. But it's also very, very challenging. So for the moon, we first of all faced different topics, started to find out and analyze where to start first. So we decided to go with the mechanical parts. We wanted to survive on the moon, and the most challenging part was for us, of course, the regolith. One of the reasons why we are here at Rostock Lage at the airport and at the facility, which is named #TheMoon, and it has this very, very, very great regolith simulant, which comes very close to this on the moon. And so after designing the first technology, we were then going to find out how our drive system should look like. We didn't want to copy what's already been existing. We read a lot of papers and stuff about the technology itself. For example, the rocker chassis, rocker bogie chassis, why it's been created, And then we also looked up what is the future of space, what is the future of moon and lunar technology. So we created our own version, and this is what you can see at the HiveR. We also realized that we have to go in two directions. One is the moon, and one is, of course, earthbound technologies. And that's why we have finally designed two different versions of our rovers and two drive system. The one for the moon is currently still a bit restricted. We are testing it, and yes. So one thing how we test things is using, of course, this test yard where you can see the second stream where students are currently using our rovers. The second is also by testing it in space. So we have two missions currently running. One is a very exciting mission together with the exploration company where they test their own capsule, the Nix capsule, where we have put some of our mechanical parts within a small container. And then together with the Nix capsule, we will be get launched by SpaceX into the low Earth orbit, where we can first of all test how the mechanical parts will react finally on the whole load of the launch vehicle. And the second is then testing it in 0G. And then finally, if everything works fine, the capsule get deployed and will land back in the ocean. And we can get the samples back and then see all the impacts together. I like what happens in terms of a crash. Will also the survive? Will their drive system survive it? And how will they survive it? How can we do it better? How can we improve stuff? So this is a very interesting mission, and we will hear a lot about this from Lennart just following afterwards. The second mission we will have, and we are very excited to be part of, is the Artemis 2 mission, where we will deploy a satellite, where we will test the electrical components of our systems, where we will test if they are radiation hard, how is the impact of radiation, especially if it goes through the radiation belts, the Van Allen belts. And so this is also something which is very, very exciting. And hopefully here everything will start by the end of next year. By then, yes, it will be a 12U satellite. We have great partners like BST. There's called Berlin Space Technology here in Berlin as well. We have, for example, Land Space, which helps us with the structure. We also have ISP technology, who gives us the propulsion system. And with all these things, we are going a new path. We are also trying out new technologies. And this will be the second very exciting mission. And why we are doing it, we want to make sure that everything is finally working and we can rely on our technology when we are launching it to space, especially to the moon. Yes. So I hope you will follow our way, why all the way to the moon, and I hope you will enjoy the day today with the speakers, with the rovers, and I hope everything works out fine. It's always challenging as we are a small team, and we hope we can manage finally.
Thank you so much, Irene, for being here today. And now we have 5 minutes for Q&A. So please leave your questions in the stream chat on YouTube. And in the meantime, while we are waiting for questions from the audience, I have a question to you, Irene. Could you please tell us more about why specifically Moon is so important for space exploration, why it's so important to start specifically with the Moon? What benefits does it give for further space exploration of like other planets?
I think it's important to go also out of Earth to go and explore. It's not only the common human sense, like exploring something to, I don't know, see what's going on there, but I guess creating these kinds of harsh conditions makes us think different and create new technology, and also especially technology which currently does not exist because we do not have the harsh condition up to now. And if you look up how space technology has meanwhile created so much here back to Earth, which we call transfer technology, and which how people could benefit finally from this type of technology. This shows how important it is. By the way, there are so many countries participating, so it is important to be part of this and not to miss it out. And it is always important to, go further, try to
Yeah.
find out more.
Mm-hmm.
And you never know, actually, you can never guess how things will develop finally. So I think the best examples are, for example, mobile phones or yeah, and computer technology in general. And it has just basically created a new world. And it was absolutely not clear where it's going to be. For me, I'm also a semiconductor. Uh, I was learning semiconductor technology as well, beside RF technology. So here was something which was called gallium nitride, which just recreated a lot. And I was working like more than 15 years ago, meanwhile, on this basic technology where everything was quite new. And now I can see the impact of this new type of technology. So gallium nitride, without this, you wouldn't have these flat screens, because this was the material which created blue light, with which you can create white light, and everything got flat. And also um, the gallium nitride, which now speed up systems with these fast charging methods, and gallium nitride is also used for space. So at the beginning, it was very, very hard to realize where technology is going to, and now after years, we can see the results, and it's actually hard to get rid of them again. So yeah, very excited.
Yeah, amazing, Irene. And just like the last question for the last 3 minutes, we have you're a female founder in such a really tough field of aerospace, and you're a startup founder in general. And we are all, I'm pretty sure, really curious to hear about what insights you've gathered in the past 3 years of you being an entrepreneur. Basically, give us one thing, one most important lesson you learned as an entrepreneur um, in the last couple of years that you've started Neurospace and been running Neurospace.
Oh, well, the hardest thing is actually not to give up.
Mm.
You will always face people, and most of them will say you won't manage this, you can you can't do that, and that's so unrealistic, and so on, and not listening to them. Choosing the
Right.
right advisors, that's something which I can say. Always good to have
Yeah.
people who helps you, and always good to ask for advices and help, but never give up.
Yeah. Relying on people who support you is very important. And Irene started from scratch, and now she has a company, she has many employees, and she has a prototype of a rover. So very exciting. And we are happy to have you here today. And thank you so much for joining us to share this motivating story. And
I would like to take the last minute to thank my team. They did a really wonderful work. I'm so excited. Also, it's only them who made it possible. So it's so great to have such a great team. So here on site, beside Iryna, of course, we have Igor. He's our CTO. We have Rick, who is running the rovers. We have Elaine. She is on the field. You can see her with the mask. We have Ellen, who is contacting the whole students and doing all these students group stuff. Um, and we also have an intern who's just 16 years old, Norman. He was just here. He's incredible. He does a lot here, and he's here for the second time. Of course, the other team, which is working there, you can meet them, and I hope you have a lot of fun with them as well. And thank you much. Thank you, Regan. Thank you, Noah. Thank you, Leonard. Thank you, Carsten. Thank you, Cornelius. Thank you, Margarita. And yeah, I hope I didn't forget anyone. I want also to thank Johannes and Oliver to support us. I want to thank Matthias. And yes, I hope I did not forget anyone.
Yeah. We have many people behind this event, and
yes,
it's amazing that we managed, to pull the whole event. And
Tobias,
really
thank you.
Yeah, thank you, Irene, for being here with us today. And we will also move on now to hear more about Lennart. And I will give Lennart a brief introduction right now. So, Lennart Fox has studied mechanical engineering and aerospace engineering in Germany and the Netherlands. And his profound passion for space exploration was evident during his academic journey, where he focused his thesis on pioneering topics such as 3D printing with lunar regolith and a design of robotic arm for use on lunar space. And at Neurospace, he's responsible for the mechanical design of our HiveR rover. And so today he will discuss the engineering marvels that contributed to the success of Apollo missions. Thank you so much, Lennart, for joining us. Welcome. We're excited to hear more. Lennart, we cannot hear you right now. Lennart, we cannot hear you right now.
We have some mic problem. We will fix that one. And sorry.
Yeah, we just have an audio problem on the speaker side. It will be resolved within the next few minutes, so stay tuned.
Can you hear me now?
Yes, we can hear.
Amazing, Lennart. Thank you for being with us today.
Thank you for the introduction. I would like to talk a little bit about the engineering that made Apollo a success. And this is not my findings. This is according to NASA. So there's a document. It's called "What Made Apollo a Success," and this document highlights both the project management and also the engineering that went into the Apollo project and eventually got us on the moon. And I think that we can even today learn from this document and also from the findings that the Apollo engineers made. So I would like to go through it, highlight it a little bit, and in the end, If you want, you can download it for yourself to have a further read. During my research, I came across these 4 sections that the engineers have separated the Apollo mission into. So they said the 4 key components were launch vehicles and launch operations, meticulously planned and executed flight missions, the super reliable space hardware, and the exceptionally trained and skilled flight crews. Since the time is limited today, I will not be talking about launch vehicles. The Saturn V is such a big topic on its own. Yeah, I think this is maybe for next Moon Day. But the remaining 3 categories we will dive into today a little bit. So let's start off with the mission planning, the flight missions, how this started. So the Apollo engineers, imagine we are now in a time where Gemini and Mercury are a thing. We have put people into space. We know how to do that part. But now the question is, how do we get from Earth orbit to footsteps on the Moon? So this was the first question the Apollo engineers had to ask themselves, is what would be the best series of mission to achieve a successful human lunar landing at the earliest time? And this question had to be answered in a flexible and yet disciplined way, because you never know when a mission fails or you have new fundings or get fundings cut, then you might rearrange your mission. So it needs to be flexible, but also very disciplined, because you need to make sure that every mission has what it needs to bring you forward. And this is the second step, actually, to design each mission to meet the largest number of operational and hardware objectives, because in the end, the goal was to get there as fast as possible. So what happened is, for example, with the Apollo 9 mission, which we can see here, the main purpose was to qualify the lunar module for crewed lunar flight, in order to demonstrate, among other things, that it could perform the maneuvers in space that would be needed for a lunar landing, including the rendezvous and docking with the command and service module. So if you imagine the lunar landing, you had these 2 spacecraft, the lunar module and the CSM, and the lunar module went down on the surface of the Moon. The so-called Eagle has landed, and the other module went around the Moon. And then when the lunar module came up, they had to re-dock to each other. Sorry? Did you say something?
Sorry, it's fine. Please continue.
Okay. And these 2 modules then need to rendezvous again. And the rendezvous profile for Apollo 9, for example, was designed in a way that in a single Earth orbital flight, all of the normal and abnormal rendezvous conditions were planned to be practiced. So with the lunar module active, with the CSM active, with rendezvous from above, from below, with all different lighting conditions. And they did this all in one flight in Earth orbit, but they simulated, so to say, the conditions that would then later arise on the Moon. And all this while also using the navigation and propulsion systems of both spacecraft. So they had one mission, but they tested both spacecraft to the extent. And this was really much the philosophy behind the entire mission scenario. And all these designing of the missions led to the build-up of the Apollo mission capability. So each mission used all the procedures, all the technology from all the missions that came before. So that in the end, the Apollo 11, the only remaining tasks were the descent, landing, surface operation, and ascent. Everything else, getting to the Moon, rendezvousing, landing, and so on, landing back on Earth, and so on, all this was already dealt with by the beforehand accomplished missions, Apollo 4 to 10. For example, 4 and 6, they considered the spacecraft, the Saturn V development and the spacecraft re-entry back to Earth. And these two steps were crucial for all the subsequent missions. And so there was a continuous build-up, and in the end, we were able to land on the moon because all the other steps were already taken care of. And the third step of the mission planning is to deal with all the what-ifs. And this is a very, very big one for Apollo. So you need to, at some point, you need to ask, okay, let's imagine 2 or 3 data sources show different results. Which of the sources should be believed and which should be discarded? And then you had to determine limits for each system and make logic flows for every conceivable situation. And not just what if this happens, but also at what stage. So you have to be specific about the mission phase as well. And each of these events, there were like thousands of what ifs, and each of these events was documented in a so-called mission rule, a document that you can see here in the middle. And these mission rules, they were set up long before the flight, and they were placed under configuration control as well, like everything in the Apollo system. And that way you had playbooks for every imaginable scenario. Now that the mission planning was done, you needed, of course, someone who controls the mission during flight, and this was the flight control. There was flight controllers that could compare, for example, trajectory data from different sources. So they could tell the crew in nearly 250,000 miles away to ignore some alarm that goes off, because they were sure that the spacecraft was guiding them correctly. And this was very, very crucial. And these mission control centers, they were operated 24/7 during the mission. They had specialized teams for all the subsystems, and they got the real-time data feed to look into. And in addition to the mission control, you had these flight control procedures. So these were basically master plans that spelled out each step of the mission, minute by minute. They included crew procedures, checklists. They were developed through rigorous analysis, and the step-by-step sequence for each spacecraft activity, each maneuver, each propulsive burn, everything was worked out well in advance so they could use it for practice and for testing. And they had the plans already ready and tested many times when it came to the actual flight. And yeah, this concludes my mission planning. Let's move on to the second component, or the third, however you want to see it, but it's the reliable space hardware. How do you get hardware reliable? And during my research, I came across 7 human spacecraft design principles. The first one is use established technology. Do not reinvent the wheel. Whenever you have something that you've tested before, use it. Second one is stress hardware reliability. The Apollo engineers, they performed not only comprehensive failure analysis, but also single point failure analysis to find every imaginable error that could happen. And then through a series of iterative design reviews, the engineers eliminated or at least minimized each potential failure point. And this is very important. These reviews are something that we do today because we've learned it from Apollo, actually. Third one is comply with safety standards. Many of the failures that the engineers found, such as structural failures, ruptures, fuel leaks, hose tubing failures, maybe electrical shorts and fastener failures, all this can be avoided by just complying with the standards. And if you have it already, then use it. Number 4, minimize in-flight maintenance. What I mean by that is, do you really want to use your precious astronaut time to find an issue or an error during flight? And according to Apollo, the answer is no. You want to have as much data sent down to the ground so that the specific specialists, subsystem operational specialists and design specialists, They can take their time. They are available, free to concentrate continuously on the resolution of the spacecraft problems, and that relieves the crew from, like, on the one hand, from their time in flight, but also from training requirement, because they didn't need to be extremely familiar with every single subsystem of the spacecraft. Number 5, big one, simplicity and redundancy. This comes from a combination from aircraft design and missile design back in the 60s. So simplicity is you build it simple, and redundancy is, and then you double up on as many components or systems so that if one fails, the other one takes over. So here on the left-hand side, we can see an example for simplicity. And sorry, Neurospace team, can you mute yourself, please? Hello, can you mute yourself, please? Okay. And yeah, simplicity, an example is, for example, the hypergolic propellants. So these propellants, they ignite themselves. They don't need an ignition source, and that makes them extremely simple in both operation and design, because you fire and they fire. Done. No additional parts required, no ignition source or anything like that. And the second half is redundancy. The example for that is on the lunar module, there were 3 redundant fuel cells. So if 2 fail, 1 could still get the entire mission back to Earth. And that is redundancy. But regarding simplicity, there's 2 kinds of simple. There's the so-called simple in design and simple in operation, and simple in operation and complex in design. I just talked about the rocket propulsion, so this is clear. What I mean by complex in design and simple in operation, I have an example for that as well. This is the command module hatch. So this hatch consists of about 400 individual parts. So it's very complex in the design, 400 moving parts. But it's very simple in operation. A single astronaut could open the hatch with a single arm in 10 seconds. And that is super simple in operation. So these 2 kinds of simple were used in the design. Number 6 on our spacecraft design principle list is minimize interfaces. And what I mean by that is if you have 2 big complex pieces of hardware, you want to have the interface between these hardware components as simple as possible, so that a single person can fully understand the interface and can cope with all the effects of a change on either side of the interface. For example, between the lunar module and the command and service module, the 2 spacecraft of Apollo, only 36 wires connected them. And this is including redundancy. So these cables are already redundant. So this is a very small amount of cables for such a complex system. And then the last design principle would be automated repetitive tasks. So this is regarding human-machine interface. And in general, you can say that tedious repetitive tasks are best to performed automatically, while, for example, the selection of the best data source to use, or selection of control modes, switching between redundant systems, these are all tasks that are performed by the pilot. So now that we've designed the spacecraft in a reliable way, we need to test it. And this, regarding, or if you trust the Apollo NASA engineers, they say the single most important factor leading to the high degree of reliability of the Apollo spacecraft was the tremendous depth and breadth of test activity. And I've also compiled some testing lessons here. For example, the Apollo, during Apollo, there were many failures or discrepancies, basically daily. But the results, no matter how big or small the failure was, failure had to be understood, and some corrective action had to be taken, and the entire thing needs to be documented. Yes, so regarding my testing lessons that I've collected, first one, development testing as early as possible. So during your first idea, do a test to check if it works, that the design is proper. Secondly, if you then do later qualification testing, do it at the highest possible level. You don't want to break your components, but you want to test them thoroughly. Third, qualification test specimens should come from normal production. So you don't want to produce a test specimen while knowing that these will be test specimen. You want to make them all like they were for flight, and then you take some to do testing. And fourth, make them rigorous and complete, but stay realistic. You don't want to over-test. You don't want to do corrosion tests for a component that will be never exposed to corrosion. And then the final one, carefully document, track, explain everything, every mistake, every error, every failure, and then take necessary corrective action. To give you an example for acceptance testing, during Apollo, 11,474 tests were conducted regarding the vibration of different components and parts. And of those 11,000 tests, 5% failed. So 20 out of, every 20th component that was meant to put into the spacecraft, where a human would have flown to the moon with, these components failed due to workmanship and to design. And for the thermal testing, it's 3,685 tests, and of those even more, a higher percentage, 10% of these failed, although they were actually ready for design. So make sure to test early and test thoroughly to find your errors. And this concludes my my section about reliable space hardware. And now we come to the last step of today's presentation, which is training the astronauts. Imagine you have these 18 highly skilled men, sadly only men, no women, and of those, 13 had already flown to space before. So they are already proper pilots, so to say, but they needed to become so much more. They needed to become computer programmers, operators, space navigators, guidance experts, propulsion engineers. They needed to become fuel cell power managers, environmental control system expert. And you see, the list is long, but the final point has even more points under them, because they needed to control the spacecraft not only in one scenario, but in 9 different scenarios, such as launch, translunar flight, lunar orbit flight, lunar landing, rendezvous, docking, and re-entry, and so on. So there are so many scenarios in which these people needed to control the flights and the way, or the spacecraft. And the way they did it is by very thorough simulation and training. And they had specially developed different kinds of testing devices, such as a special dynamic launch simulator or mission simulators that you see here in the bottom picture, that could duplicate here on Earth every spacecraft function and display under all possible conditions. So very, very complex system. But my personal favorite is the flying lunar landing training vehicle that you see on the right-hand side, which was equipped with a jet engine that constantly fired downwards, or actually fired in the direction of the gravity vector with 5/6 of gravity, so that the flying vehicle behaved the same way as it would in lunar landing approach. And all this rigorous testing, simulation, then 55 years ago, finally led to the first moon landing of humans. And this pretty much concludes my presentation. I have one more lesson, and this is, I think this is overarching a consideration that's overarching all of the others, and that is attention to detail. Painstaking attention to detail, coupled with dedication and this at all levels by all people on every single element of the Apollo. What led to the success of one of the greatest engineering achievements of all time, to put humanity on the moon. The legacy of Apollo, in my opinion, is mostly innovation and inspiration, both in the engineering and also in the project management sense. And yeah, I'm curious to see what's happening next, with the lunar economy growing. As we look to the future, I think we should be inspired by the ingenuity and determination, also the collaborative spirit that defined Apollo. And yeah, maybe we can carry forward the legacy of exploration to new frontiers in space. Here now you have the possibility to download the document that my presentation was based on. And with this, I would like to thank you for the attention and enjoy the International Moon Day.
Thank you so much, Lennart, for being here with us today. We have basically 4 minutes before the next speaker joins us. So just one question to you, super quick. What would be one advice you would give to someone who is now young, let's say a teenager, and wants to go down your path, wants to study aerospace engineering and be an aerospace engineer at a startup or at the company that basically deals with space? What would be the advice you would give them right now?
I think the biggest advice is to stay curious, to always follow the path that your gut feeling tells you that is interesting to you. It makes no sense to follow something because other people tell you this is the right way. Listen to your gut feeling, but also at some points you need some discipline to stick to it, and then you will get where you want to be.
Amazing, Leonard. Thank you so much for joining us. We really appreciate the effort you put into this presentation. It was really well made, and thank you for all your knowledge and insight. It was incredibly interesting. At this point, we will take a very short break for a couple of minutes before we welcome our next guest. So stay tuned. Hey guys, we are now back with Ricardo Peña. I will give him a short introduction. He's a software engineer at Neurospace. He has previously worked for 7 years in commercial aircraft interior development and had some internships at JPL. Welcome, Ricardo, and we are looking forward to hearing from you.
You see my full screen? Let me try this again then. Sorry about this.
Amazing. You can share your presentation. Thank you.
Okay, let me just get started so we don't waste time. So basically, what I wanted to do today was present to everyone the results that we had from our Volcano summer school. I'll go into a little bit more detail about what summer school is. And I just want to give credit to my colleagues, Tobias Panzer and Soohong. They were there with me testing this whole time. Okay. So first of all, I wanted to let you guys know what we were testing. We have this platform called HiveR, and basically it involves having 4 tiers, starting with an academic one that we use for development and testing of science, usually in a university setting or a research setting, all the way up to the space grade system, which is what you would see on the moon or on Mars. And of course, you have everything in between, which is something used for like an industry or something like used for in very hazardous regions or terrain. So you obviously have to be able to develop and test for all of these different designs. But like just to discuss I guess the most difficult one would be the lunar environment, which we have to discuss radiation. Then also we have to be concerned about thermal because of the extreme temperature ranges from cold to hot. Obviously, difference in gravity. It won't behave exactly like it does on Earth. Dust, especially in the moon, is very, very fine and very, very sharp, and it tends to get into these very, very tight spaces, which makes is very, very dangerous for all electrical systems or all computer systems. This is usually the biggest failure point in most lunar missions. And then we have the vacuum, but for this one, we won't get too much into this because it's really difficult to test vacuum anything on Earth, an environment. But here are the test subjects that we were using in Volcano. So the first one is our standardized model, which is what you would see like in the moon in the moon yard that we have here, or like what we sell for the academics. And the other one is this very customized version of our rover that we developed in collaboration with another university for them to do some attach some magnetometers to measure the gravitational field around the volcano because of all the ferrous material that's in the region. So they wanted to basically just to explain why they wanted to do this is that they basically right now what they would have to do is carry this pole that you see on the right side on the rover and move from one point to another personally and take the measurements independently. So what they wanted to do is maybe to see how feasible it was to attach it to a rover and basically kind of automate this task. And it would also enable them to send them to more hazardous regions where people can enter. And the reason they wanted to do it with a rover is they just want to see how the equipment would interfere with the electronic equipment of the rover itself. So why the Volcano Summer School? So the Volcano Summer School actually is a very varying region. Like it offers different types of terrain. There's a lot of different views. Just the areas for like which regions per. There's also like a very nice theory, just kind of like the main point that we want to do this is that we wanted to really use the rover in the field and see if they behaved in a way that we hadn't really accounted for, which, as you will see in a bit, it actually did. So basically, I just want to review the conditions that we saw that you can see, you can expect in Volcano. So for as far as the heat, it's the temperature that we saw were up to between 28 and 34 degrees during the day. But of course, we have very direct sun exposure in the middle of the day, which really heats up equipment. Then in the main crater, there's a lot of very large rock formations. There's very steep inclines to almost 40 to 50 degrees, some even up to, I would say, 60. And there's a lot of fumaroles, which is just basically these sulfur, this sulfur coming out of from the volcano. That's this vapors, which also tends to oxidize equipment. So we want to see how just being around it would affect the rover. And there's the Moon Lake, which is a very flat region with very fine dust, and which also has, as you can see in the very bottom image, it has a lot of a lot of medium-sized rocks. So we just wanted to see if the rover had issues overcoming this, mostly for the rover with the magnometer equipment, which is attached like almost 2 meters above the center of gravity. Just so you can see kind of what some of these regions look like. Okay, so we just wanted to go mostly through each of the regions and what the behavior that we saw from the rovers. So in Rio and in Fossa, we saw that so we actually had a lot of overheating from the motors themselves. But this was generally not because so we saw that it's not a mechanical issue or a thermal issue from the motors themselves. It's more a software limiter that is set to 50 degrees, which is appropriate based on the data sheet and specifications of the motors. But the motors, we removed this limiter just to see how far it could go. And we were able to extend operations to 40 minutes. Before we removed the limiter, operations were basically restricted to between 5 and 10 minutes because it just heated up so quickly. Then some things that we saw also because of all the cliffs, especially in like Rio and in Fossa, when we had an operator just using the camera, we saw that we really couldn't determine our position and orientation, like whether we were going up or going down a hill or something like that, because in the camera, it just seems like it was an even surface. So we saw that basically the IMU data was we were missing the data, and it made it almost impossible to determine our position and orientation. We also determined that we had some issues with the temperature calibration from the chassis PCB. And in some instances, we noticed that the shutdown sequence for rover was a bit faulty. And the reason I'm mentioning most of these is because these are all things that we really hadn't seen from prolonged operation. So it was very important. It was really important for us to see this in the field, and especially after operating it for very high temperatures. And then the Moon Lake. So in the Moon Lake, we have similar things with the thermal limiter. Like I said, with the software, also operations were restricted. But in this one, because it's so even, and we were able to basically go over rocks and stuff, what really became an issue for the magnetometer equipment. So this pole, we really hadn't intended for a design like this to be used. So the placement of this equipment so far up above the nominal CG of the rover really made it unstable, very unstable. So we really required to be kind of like very slowly and run these very large rocks. It's not so much that the pole would move out of place; it's just that it's not a very structure. So then it was always oscillating from side to side, which made it very prone to tipping. So this was again something else that we noticed that we really need to study and see how we could overcome this. And then, as I previously mentioned, the magnetic perturbations of the rover equipment on the magnetometers. But these were we kind of already expected this. We're still waiting on the university that we're collaborating with to tell us whether this is something that can be overcome. But as far as we can tell from the measurements, I mean, they were able to gather at least very useful data from the field. If you see the second video, you can see how the just thinking about when I'm talking about the oscillations that are causing the tipping. And this is basically it. So if you have any.
Thank you, Ricardo, for joining us today. We really enjoyed your insightful presentation. Just a question for you for Q&A. Could you please tell us more how you got on this path of engineering and your interest in space? Why do you think it's important for humanity to start exploring space, in your opinion?
Yes. So actually, I a few years ago, let's say I was always in aerospace. So I was always very motivated to work in with airplanes and stuff anything in the sky essentially. And a few years ago, I was working with in my previous university with the satellite development, and I was just so amazed about all the technology that goes into it and the innovations and ideas that are used just to collect data. And even in the summer school, for example, a lot of scientists were presenting their data, and I was just amazed at all the techniques and that they were used. Like, for example, that you can just use some sensors from satellites, and you can pretty much determine what the composition of the atmosphere is. So it just, for me, it's just more that the more we participate in space and the more we are able to research and stuff like this, it just really shows us that we really have so much to learn about space, and it really teaches us a lot about this technology that we find that we develop for space is so translatable for here on Earth. For example, the MRI machines are basically a product of space research. And right now is one of the most important medical tools that we have on Earth. And I can only foresee more and more tools and ideas that are going to be developed because of space exploration.
Sorry, could you hear me?
Yes.
You had some considerable experience working at Neurospace, and so we wanted to ask you more about the insights you got while being a part of a startup, specifically aerospace startup. Well, we know that most companies in aerospace field are usually huge companies, and there could be a difference in working for big aerospace companies, working for startups. What do you think for you personally? What advantage do you think you got from working for an aerospace startup versus a bigger company? And why do you think it's a beneficial experience to have an experience at a smaller firm for either skill development or community? Thank you.
So yes, this is it's a great question actually. Especially because I first started working at a larger company, and yes, like what you said, when you're working at a larger company, I think I'll start with this. You are more specialized in a section of the product or service that you offer. So you really at the begin in a larger company, I think you're much less flexible to um, to work outside of this very specific service or product or part of the product that you offer. In a startup, you really, especially because of the small personnel that you have, and maybe sometimes because it's a startup, so everyone around you is also kind of like just barely becoming experts in their fields, like they're developing professionally. So for them, it's also a development phase. So you have the ability to really work on every part of the product of service from the startup, because everyone needs to help, and you need hands-on. Basically hands-on deck on every single part. So, for example, for me personally, I focus a little bit more. I focus on the software side of things, but because we all need to work together, I have been exposed to working in some of the electrical systems. Sometimes I do have to help a little bit with the mechanical side, with assemblies, wiring. So it's a lot of things that if you're at a larger company, you have very specialized people for this, so you would never have exposure to this. So I think starting at a startup really helps you uh, develop a great foundation of skills that are basically make you a more well-rounded individuals and really develop your aptitudes. And let's say at some point you do make this translation to a larger company. Not only do you, of course, you're going to be a specialist and a very experienced person in your field, but now you have the ability to communicate with other departments and other engineering sectors and even some non-engineering parts of the company. And you're going to be able to understand and communicate very well with them. And also, so basically, you become more of a systems engineer, and people are going to look to you for guidance because you're the person that they can communicate and get their points across, and there's not going to be a lot of confusion. And I think you get this because you develop a really good base and a really good experience, well-rounded experience by working on a lot of things in the startup. I hope this. I maybe got a little carried away, so hopefully I did answer the question.
That's an amazing answer, Ricardo. Thank you so much. So basically, working at the startup gives you an opportunity to develop more versatile skills. And at bigger companies, you're more specialized in a specific thing. And of course, at the startup, there is more
Exactly.
flexibility. Um, just another question while we still have 10 minutes to go. Um, how do you personally see space exploration going further? Do you see people building space habitats on the moon or any other planets? How soon do you think we will be able to achieve it in the near future? What do you think? There are a lot of questions. I can just repeat them later on. And like, what do you think are the main challenges of currently exploring space and getting out there?
Okay. So I mean, I really think that habitats are something that I think it would be, especially since we really haven't found signs of life, like intelligent life out there. I think space habitats are really, really something, the next step in exploration. We've already send a lot of probes elsewhere, and it's of course it's we the next thing is to see with our own eyes what's out there. Um, I really think that right now, well, one of the biggest hurdles, if from the geopolitical standpoint, is mostly that we have funding for it, because it's really hard for people to invest in space because they don't really see a concrete result or a payback from it. Like so a lot of the money, the investment is very hard to obtain some kind of return on it. Uh, at least for main investors and for governments. So there's a little bit of a hesitation to provide funding. And but with the privatization of space, this is becoming more and more accessible and less of an issue. And we're still a long way to go before we even, I guess, before we're where I think we should be. And right now, I think the biggest problem is also that most of the inhabitable planets that we've found are extremely far away. So the technology is just not there yet. But I hope that within the next, I don't know, I hope that within the next 50 years or so, 25 to 50 years, we are able to see a very significant change in the technology that we use, especially for traveling, for space travel. And even if we were not able to reach these exoplanets that are so far away, we're able to set up these habitats in closer celestial bodies, such as the Moon and maybe Mars.
Thank you so much for sharing your opinions on such an important matter. And at this point, we will take a short 8-minute break. So we will welcome a new speaker at 10:30, which is in 8 minutes. And thank you so much for being here with us today. Really appreciate it. For you guys, please stay tuned and come back in 8 minutes. Hi guys, welcome back. And we have our new speaker, Soohong. He's a software developer at Neurospace, and he worked on the R&D for our HiveR rover and developed mission control systems. Welcome, and we are looking forward to your presentation about our HiveR rover, our main product, and yeah, you can start.
So, can you hear me?
Yeah, I can hear you.
Okay. So today I would like to talk about HiveR, the next generation rover. And thank you so much for this opportunity to both Neurospace and Monday. Okay, so I would like to briefly go through the history of the rover. So it actually started from 1970s with Lunar Code 1, and you can like implement it. However, recently, as they restarted to focus on uh, we, we are actually facing challenges. The reason for that is I would say there's a whole paradigm changes in these technologies. So you can see most of the rovers that are driving back in 19, so they are really heavy and bulky, and they are equipped with like so many different payloads. However, you can see that in 2013 and 2020, the U2, those are like 23 kilos or 40 kilos, which is way less. So the main reason for this is because of the physical limitation as well. For example, going to launch something to space, a single kilogram counts as money. And we have to cut down the cost and also the and also the complexity. So you can see the tiny rover on the left low side of the picture. That's our height, and it's like 1:1 scale, like real size comparison between one rover and our. So here's our HiveR. So as briefly discussed by my colleague, we are dividing the HiveR into four different teams. So one is academic, it's industry, math, and space. And the reason that we are focusing on this is because we believe that we can do a lot better things with the terrestrial applications, not just space. So with the academic version, we're collaborating with a lot of institutes and research universities. Um, we they are actually using our exact same platform algorithms, different industries. We can freeze the robustness, also the system of our rover to actually work on different power plants and other hazardous area, other place that require monitoring. And hazmat is mostly for the hazardous environment like disaster relief purposes or surveillance of the disaster area. And this we know that it's the most harshest, it's hardest environment where the electronics and everything is changed. It's a remote area. So what's cyber specialty? So first, our rover is very simple and modular. So what does it mean by simple? As Lennart discussed, it's actually simple in design as compared to any other rovers available right now on the planet. So, and also it's payload independent. So it means that you can drive the rover. So in the left picture, the button is up to so it's like a full and CubeSat area, which is like on top of the small box, those are pretty much empty. So what it means is we can actually customize the payload depending on the customer's need. One example was we collaborated with TU Bach. So what they wanted is a driving platform where they can attach their experiment equipment to measure the Earth magnetic field.
Yeah, so on the left top corner, the picture is the product that we delivered to the TU. So it's pretty much different from full. It's mostly empty. It's a flat platform. The right side is the full setup of the that the TU Bath came up with. And believe it or not, it's very modular, and it took them less than a week to actually configure all those setups. So one of our goal and focus is to have dedicated mission per rover. So unlike other big rovers, we are actually planning to put one single mission to a one single rover. The benefit of this is one, we can actually operate multiple missions simultaneously. So if we deliver one, so one rover can do it, then the other rover can provide a mesh, then the other rover can do a sample collection and everything. However, if it's like a big rover, then everything is done in a one single platform, which makes everything harder and harder to plan out the execution of each mission. And if one system fails from the mother system of the rover, it means all the other missions are failing as well. Yeah. So that was the main reason why we are focusing one mission per rover. So for multiple missions of time and for um, safety as well. So let's go through the so one of the harshest thing is radiation. At ISS, lunar space has way higher radiation dose, which is 1,300 times microsieverts per day. And the reason that this is so important is that radiation dose is very critical for the electrical components. It can actually create some malfunction with the ROMs and CPUs. That's the reason why on the left side of the corner, doing some tests for our controllers and first thing is the thermal. So we all know that thermal environment or range is very huge. So it's varying from 233 degrees Celsius to 123 degrees Celsius. And the reason this is so critical is because of the usually battery or the chemical that we are using is only suitable for 30 to 40 degrees Celsius. So thermal research is really, really critical for any kind of subsystem to survive in the moon. So it's actually the behavior of the number of the gravity matters from the system of the rover, because same setup of the system, we're gonna react very differently because of the difference in weight as compared to Earth and the Moon, which is like 1/6. So whatever the weight that we're on the Moon will be 1/6 lighter. Okay, next. Then the dust. So the lunar regoliths are very sharp, abrasive, and negatively charged. So in the bottom left corner, this is the microscopic scale of regoliths collected by Apollo 17. That is very sharp because there's no corrosion and erosion. So as fans on really sticks into any kind of material. And also, since it's negatively charged, it also attracted or it applied a magnet system. So on the center, you can see the difference between the wheels. Those two pictures. So one in the center is the driving Nova Fleet, and right side is driving rover on Moon Village, regular simulant. So as you can see that into the grooves of the wheels, the regoliths are really sticking into it because they are so sharp and abrasive. Yeah. And where are we? So currently we are doing a bunch of testings with our rovers. So right now we're doing a lot of like harsh testing with academic version. And you can see that we're doing some field tests in a regular simulant or in simulant areas. So we're doing the wheel testings and after the spin testing because of they are super fine. And we are also doing the radiation test, as you can see on the side. We're measuring the radiation dose, the performance of our. I actually put it in radiation team. And also we're developing some payloads as well, just like a prototype version of our small one size body car. And also we're doing some human tests, just like we did in the Volcano 2024. And right now, when it comes to software side, we are actually developing a lot of like these structures, also trying our best to talk about architecture so that we can actually distribute them as an open source for each institute and universities for them to this rover work in better performance. Yeah, so this was it for the HiveR.
Thank you so much for your presentation today. It was very insightful to learn more about this innovative technology for moon exploration. Now we will move on to the Q&A, and we will start more with the personal question about how you got interested in space and what was your path to becoming an engineer for HiveR. Would be interested in hearing.
Mhm. Okay, so actually space is such a wonderful area for me. We haven't discovered a lot from as compared to Earth. We don't know a lot of things in space. And when it comes to engineering side, as an engineer, we are facing a lot of challenges because, one of the key thing in engineering is knowing the variables. So, like Earth, if we don't know, if you have any doubts about where are we running these things and how do we run this thing, what are we building these things and why are we building this thing, we can actually go to the site and we can actually test out these things. So, for example, if it is like a disaster, then man can actually go there and survey the sites and area. However, when it comes to space, it's just full of unknown variables. And it's just like we are preparing for something that will never be known before and also in the near future. And it just fascinated me in such a way that, I'm preparing at some point for the future generation as well. So that was the main reason why I decided to go into the space among the many other fields in engineering.
Amazing. Thank you for your answer. And another question is where do you see the space? What trends do you currently see in the aerospace engineering compared to the past? And how do you think the whole industry will develop going forward in the next 20 to 50 years? Do you see people building the space habitats on Moon or other planets? So what your vision is and like what trends have you noticed on the field? Thank you.
Yep. So, space trend has been rapidly changing from, I think, early 2000s. So before it was mostly only open to the government and anything that related to the public funding source. However, since the new space started, a lot of private sectors have dived into the space, and which boosted the whole technological development as compared to the past. So I would say the space industry nowadays are really open to the public and the private sector as well. And also the technological development on the same time has been accelerating way faster than the past 20 or 30 years. And one of the problem that we had before is conservatism in the space industry, because basically everything has to be failure proof, and that's the reason why we have been maintaining like such an old computer and such an old system which has been proven and tested. However, as soon as new space came, we can actually implement something new, something that has been tested, or like less tested as compared to the other robust system. And that allowed like a lot of engineers to actually implement something more powerful or something more creative to the space system. So I would say the whole industry of the space is changing as compared to before.
Thank you for your answer. And the last question I have is, you have been working at Neurospace for a while now, which is a startup, and we know it's not it's in this industry, it's more common to have big corporations who are doing aerospace development. What advantages have you seen for yourself as an employee at a startup, such an innovative startup? What skills have you gained that you think you wouldn't be able to gain at a bigger corporation? So in conclusion, what are the main advantages of starting at the smaller companies, especially when working on such innovative products and ideas?
Okay, so, well, first of all, I'm not a corporate type of guy. So what I imply by that is, I'm very sure that working in a corporate will give me a lot of opportunity to learn some new technologies and some new things. However, I like dynamic environment. So what I've felt from working in a corporate is that there are a lot of more process, and they are way more strict about the work environment. So what your work and what is your task. So they really want you to stick on that and master a specific one or specific task that they have assigned you. However, when it comes to startup, it's very much dynamic, and I feel more I feel like I have way more freedom than working in a corporate. So if I have like really innovative idea, then I can propose it, and always like our management level, they are really open to our new ideas and new implementation, and it's much easier for us to implement the new idea as compared to the corporate, because our system is still developing. And because of that, I was able to expose myself to such a diverse environment, so including mechanical, electronics, and software. And I really feel like working in a startup really depends on your level of motivation and how much you want to work on different kind of fields. So for me, like exposing myself or like dragging me out of my comfort zone is one of my passions. So like I'm always like asking for, hey, can I try this? And can I try to implement some new system? And like they're always open to this, and they always allow me to work on the new stuffs. And by doing that, by like having like side projects, I'm always gaining new knowledge and new skills as well, which I really highly appreciate about like working in a startup.
Amazing, thank you. Sounds like working at a startup gives really a lot of advantages of having more flexibility, and that's also what other speakers before you have already mentioned, but we just want to hear different opinions from all the guests we have today from Neurospace. So at this point, we will start our 10-minute break before we welcome another speaker from the industry. Thank you so much, Soohong, for your time, for creating this presentation and everything you've done for Neurospace. Really appreciate it. And now
Thank you
we
so
are
much.
going on
Perfect.
Hey guys, welcome back. I hope you didn't have to wait for too long. We have a new speaker now, Natalie. Natalie is an aerospace engineer that has been working at TAC for almost 2 years. She started at the company where there were only around 20 employees, and since that time, she has seen the startup grow by 6 times. And she began her journey at the company in product strategy, but she quickly moved to mission management before stepping into her current role in program management. So, welcome and thank you so much for joining us today at our Moon Day. We're very excited to hear about your experiences and about what you've been working on.
For the introduction. Yeah, as you heard, I'm working at the exploration company. So for the beginning of my talk, I just want to kind of give a quick overview of what the company does, what our values are, and why we're doing what we're doing. So basically, the mission of the exploration company is, as you can see here, is to build accessible, sustainable, and cooperative space worlds. And you can see in the background here, this is actually a picture taken in our integration hall. So this is the actual capsule that we're building at this very moment. And I'm going to tell you a bit more about it later on. But first about the what we're actually doing is the Nix family. So as the exploration company, we want to build space capsules. We want to be a transportation company in space. So on the one hand, we have Nix Earth, which is a capsule that is going to serve Earth to low orbit and back. And on the other hand, we have Nix Moon, which is springing from Nix Earth and is a development out of it. And it will serve Earth to Lunar Gateway and back. But first, maybe a short summary about the company itself. So we were founded in Q3 2021, so we're about 3 years old now. And the core technology that we're building is the Nix family that you have just seen. So these space capsules. We have already built our first demonstrator. We have built our second demonstrator as well, which is also completely sold out. So the second demonstrator was the first one where we had payload on board. And we've already won about 770 million euros in contracts that we have signed with anchor clients and government agencies, where we provide space capsules to them in order to fly missions in space or to serve space stations. Additionally to our contracts, we have also raised about 65 million euro in capital. So far we've been quite successful, luckily. And we also have a great team that backs all of this up. So we have about 120 team members at this point. We come from over 28 different nationalities, so it's really a very diverse team, which is something that we really value because it brings a lot of different viewpoints to the table. And it really allows us to find the best way forward for all of our problems that we are facing, all the challenges that we have. So how did we come to what we're doing today? As I said, we are building space capsules, but of course, we're not able to build a very big space capsule just on the go without doing anything first. So our mission is basically, we first built a very first demonstrator, which you can see here, Mission Bikini. Then we built a second demonstrator, which is the one that you saw in the very first picture. And now we're in the very development of the actual big capsule that is full size. But one by one, you can see here Mission Bikini. It was ready within 9 months, so it's actually quite quick because we wanted to fly with Ariane 6 and had to be ready in time for the launch, which then unfortunately was moved back, but we didn't know that at that point in time. So we actually had Bikini done in September 2022, but it doesn't have payload on board. As you can see, it's quite small. It was just for us a demonstrator so that we can really demonstrate the technology and also get data on re-entry. So it's just a re-entry demonstrator. And you can see here how Bikini was then integrated in Kourou into Ariane space. It was very exciting for us to have our first hardware actually in space and launched. And then you can see here our hardware in space. Very, very nice. Unfortunately, as some of you may know, there was a malfunctioning with the launcher with Iryna 6. So because of this malfunction, and the launcher was not able to perform the deorbit burn, and that's why we weren't able to get separated and perform our own reentry. So this is very sad for us because we weren't able to gather all the data from the reentry that we had planned to gather. But still, this demonstrator was very important for us to really start building our company because it allowed us to have a first try run basically in developing a small capsule and building something together. And then based on that experience, we have built Mission Possible, which was also a very quick development in terms of timeframes in the space sector. So we have done this within 2 years. You can see we started with a very regular design here that we had then refined. We have the OBC and DM manufacturing that we did ourselves, and then all of the integration, all of the testing, and then actually just this week we received our capsule back from the environmental test campaign. So everything is good. We're ready to fly now. We are receiving payloads in the next couple months. We're going to integrate them. We're going to close the capsule, and then we're ready for launch next year. That's very exciting for us to have our next demonstrator in space. As I said, it's not full size yet. It's a little bit smaller than the actual full size capsule. And it's also for us to demonstrate the technology. So we're going to fly up into space. We're going to be in space for about 90 minutes, and then we're going to re-enter, and we're also going to recover the capsule. You can see here the environmental test campaigns on the thermal chamber. And then the next big step is Nix Earth. So we're still on track for this one. We're in the middle of the preliminary design review at this very moment. And then we're going to fly in Q4 2027. It's going to dock to the ISS, so we are going to bring cargo to the ISS. So yeah, you can see here a short rendering of it flying in space. And basically for this one, we have several anchor clients signed already. So we have a contract with Axiom Space, with ESA, with Starlab, with VAST, so a lot of also the commercial space stations that are going to come so that we can deliver cargo to these space stations and become this European provider for space transportation that we want to be in the end. But apart from building our hardware, we also really want to be able to shape the ecosystem that we are living in. So we have, for example, co-shaped the ESA-LEO cargo return competition. We were also lucky enough to actually win that competition and to sign the contract for the ITT that we submitted. So we're very happy for this as well. And then just maybe a more detailed technical overview for the people that are interested on Nix Earth. So as I said, the maiden flight for Nix Earth is going to be in November 27. We're on track for that. We have an up mass of about 2.6 tons in the pressurized compartment, because as you can also see on the rendering here, we have the capsule, which is pressurized, and then we have the service module, which is unpressurized. And we have 2.6 tons of cargo that we can carry in the pressurized compartment, and 1.4 tons in the unpressurized compartment. So we offer different types of access for these payloads. We have the regular access, but we will also be able to offer late access so that you can load your payload very shortly before the flight. We have an average power of 150 watts that we can provide with a 28 volt DC surface. All of this at a price that I think is very good. So we have 20,000 euro roundabout per kilogram for the unpressurized compartment and 200,000 for the pressurized compartment. Oh, and very important, our capsule is actually going to be reusable, because as we said in the beginning, we really want to try to make this as sustainable as possible. But I think what's maybe more important or more interesting for today, since we're talking about Moon Day, is the moon missions that we have planned. So as I mentioned, we have Nix Earth, and this is then going to develop into Nix Moon. So we want to provide, on the one hand, the access in low Earth orbit, but also to the lunar gateway and also to the lunar surface. So we have planned a mission in 2029 where we're going to deploy 2 tons of payload to the lunar surface. We're already working on the propulsion system there, and then we're going to have basically a payload platform where we can then deploy different types of payloads to the lunar surface. But apart from the lunar surface, of course, we also can deliver then to the lunar gateway. So we just have regular cargo missions to the lunar gateway, but then just for Nix Earth, we also want to have human rating at the end, so that we can be an independent European provider for access to space, and also for both for cargo and for humans. Basically, how we want to achieve that, because as you've seen, the timelines that we are following are quite aggressive, and we're not going to be able to stick to these timelines if we don't use synergies. So our goal with all of this is to have basically base plates and then add-ons that you can add depending on the mission. Kind of like Lego, as you can also see here. So you have the capsule, you have the service module, and you have a lander base plate. And then you can add on to this depending on whatever you need for the mission. So you have propulsion, you have thermal protection, power generation, on-orbit service, recovery services, crew support if you want to have humans on board. And you can really build your mission to whatever you need, because you have this base that is always the same, and then these parts that you can add on. And then you can kind of see also here on the right side the different types of missions that are possible then. So it really is very, very individualized, but using all the synergies that we can use to make sure that we stick to a very tight timeline and being able to provide services as soon as possible. And I think that brings me to the end of the presentation already. And I'm very open to any questions that you have about the company or missions. I'm happy to dive more into detail on anything. I just want to give you a quick overview of the things that we're doing. And then let me know if you want to know more about anything.
Thank you, Natalie. So we are going to start our Q&A now. The first question would be about how you decide to become an aerospace engineer, and we know that you first started in the product management role. So how do you think, so what was your career path, and like what made you passionate about aerospace?
So for me, I started studying aerospace engineering because I loved space, and during my studies, I kind of discovered that, of course, space is super exciting, and I love the technical stuff, but actually, I really also liked being able to talk to people and not just sitting in front of my computer doing calculations all day long. So for me, it was just kind of this revelation that being an engineer, it does not have to be to always just do calculations and be very nerdy in front of your computer. I love that as well. But I love to also have these interactions with customers. So that's why I went into the mission management, because you have this very nice fusion of kind of a business aspect, but also a very technical aspect. And then I moved on more to program management because, as I said, we had Mission Possible, which is kind of built right now and not completely done, but on the verge of being done. So I wanted to have a new challenge, and that's why I moved to program management, which is a bit less technical, but it's very interesting because you have the overview of every single subsystem, and you really see how everything works together. So you really get the overview of, okay, when does GNC need input from propulsion? And this was, for me, being at a young age still in the beginning of my career, very helpful to really understand a system in its whole manner, like really the overall system, not just one part of it. And I really like that.
Amazing, thank you. It seems like a very interesting career path, because I've seen that you studied engineering, but you were in the role of a product manager at an aerospace company. So I think it would be interesting. It was interesting for everyone to hear how you went into more, people's role, I would say, while still being involved with aerospace. Another question I have is, um, from being in the field, how do you envision the future of aerospace engineering or the future of space in the next 20 years? Do you think people will create space habitats, or like what do you see us exploring as a human civilization?
I think space is going to be more and more accessible to everybody, because we already see all the commercial space stations coming up. As I said, I mean, also we as a company have signed several deals with commercial space stations, and these commercial space stations, of course, they want to make money, so they're going to offer access to space to everybody, and not just governments, but everybody who can basically pay for it. It's going to be expensive, but I do believe that this will become more and more accessible. But from my opinion, it's something that we also have to pay very careful attention to, because space is cool for sure, but a launch does have quite the impact on the environment. So it's something that we have to be careful to make sure that even though we get more access to space and make more use of it, we do it in a sustainable manner. So for once, making sure that the launches are as least impacting as possible and to limit the launches as much as possible. And on the other hand, to also make sure that we limit the space debris that already is a big problem. And if we get more and more launches, going to be just worse. And I think this is one of the main challenges, to really make sure that space is staying accessible for the long run and to develop space exploration in a sustainable manner.
Yeah, those are really important points. And actually, the next question was going to be about the challenges of space exploration, but I think you really touched on that already in your answer. So another question would be, um, we've been really experiencing how AI now impacts our daily lives, and I'm interested in hearing whether you in the field already experienced some impacts of AI specifically in aerospace, or alternatively, how do you think AI could help you do your work, or how do you think AI can help all the like aerospace engineers and development of the industry in general?
I think AI is something that we definitely should pay careful attention to, because it's something that can really help us a lot. I think there's a lot to still be done for it to be at a level where it's super, super helpful, but I think it is something that we should develop. For example, if we go to navigation and docking, things like that, I think AI can be quite helpful to make sure that this is as safe as possible with the algorithms and the way that you use it. But I also think just in general life, for every engineer, of course, you have to do a lot of documentation, things like that. I think if you're able to train an AI to really assist in providing documentation of the work that the engineers are doing, so that the engineers can actually focus on the engineering parts and designing and everything, and not have to spend a whole lot of time on documentation, I think that is something that can really aid every single company as well.
That's amazing. Thank you so much, Natalie, for being here with us today. And thank you so much for your presentation and sharing really interesting insights about your career and, how you see space. For myself, I really learned a lot today from you. So thank you so much. And now we're going to have a break for 10 minutes, and then we're going to welcome another speaker.
Thank you. Bye.
Okay, guys, I hope you stay tuned. Right now, you're seeing the view from our rover that is now being driven by different groups of students from all over the world. Their task is to try to scan the QR codes that you can see right now on the playground and then have a quiz about uh, space exploration. So we are now taking a longer break between the speakers. The break will last from now until 1 p.m. Berlin time, which is in 1 hour and 18 minutes. So at the moment, you can see the stream of our rover playground, which has very similar conditions to the moon in terms of the sand and the rocks. And you can see how our rovers are being directed. And then we're hoping to see you all back at 1 p.m., where we will have 4 other great speakers from different companies who have expertise in aerospace. So stay tuned and see you in slightly more than an hour at 1 p.m. Berlin time. Okay, guys, welcome back to the Neurospace Monday event. We have another speaker with us today, Giannis. We're very excited to hear about the importance of moon rovers on the moon and why space exploration is important in general. So could you please go ahead and introduce yourself?
Hello everyone, my name is Giannis Vardanikas. I am a master student of space engineering in Technical University of Delft. I was the project leader, I'm still technically am the project leader for Lunar Zebro, for a university research project of TU Delft for the academic year 2023-2024. And yeah, I've come here with the recommendation, of course, of Dr. Rajan to give a short description, a short presentation for Lunar Zebro. So yeah, without further ado, I would like to give it a start. First of all, a few words about the contents of the presentation itself. 1 second. There we go. I will first give a few words about the lunar exploration in general, in the sense, and basically tell you that there is a need for a platform in the current sector. Then give some a short description about Lunar Zebro, about the whole project. Also give a mention to one of our sub-projects called Tracy, which focuses more on the terrestrial rovers and their development. A short timeline, a few words about the team, and of course, in the end, Q&A, where I hope I can answer all of your questions. First, I mean, you must know better than all that there has been a revitalization in the interest to explore the moon for research and continuous human presence lately. And this has been expressed with, in particular, various missions that have happened or are currently being developed in various phases from space agencies, which you can see on the left, as well as companies from the private sector. And in a more broad sense, space exploration has been also something that TU Delft has pursued in the past with 3 satellite missions. In Earth orbit, of course, of Delphi C3, NEXT, and PQ. And what we envision is to bring TU Delft one step further into space exploration and join the current trend of exploring the moon, actually, and being able to aid the exploration also of various other companies and agencies, of course. In more particularly, with the support of the Space Institute of TU Delft, as well as the Robotics Institute, the Moonshot Program, and RoboHouse from TU Delft as well. We intend to aid with creating a platform for robust lunar exploration. More particularly, we want to make in situ measurements on the surface of the moon, basically, as well as characterize and map the lunar surface, while also being able to create a standardized and scalable platform, more to be able to aid the further development in the future, actually, for different purposes. More particularly about topics of scientific and technological / engineering nature, such as swarming, sensing, mapping, and radio astronomy, or you name it, other fields as well, as more long-term goals for the project. And this basically brings us to Zebro. Zebro is a word that we created, actually, from the 2 words in Dutch of zesbenige robot, which means in Dutch the 6-legged robot, which is derived basically from the nature, from the interesting and innovative, I would call it, locomotion feature that the rover has, with the C-shaped legs, as you can see, 6 of them, which work independently. more about that actually later. Here you can see some other technological engineering features of the rover that are being currently developed for our first lunar mission, actually, which we actually have given 6 discrete mission objectives. First of all, we want to be able to operate for 1 lunar day on the surface of the moon, which of course you might know that it equals to 14 days on Earth. Secondly, we want to demonstrate the C-seat legs, the locomotion concept of these legs that you saw before. We want to basically show that this is a viable engineering solution for locomotion, as opposed to other means of a more conventional nature, such as, of course, the circular wheels that have been used before. Thirdly, we want to demonstrate a bidirectional Earth-to-Moon communications link. Also demonstrate agile, semi-autonomous surface navigation, which is actually quite a challenge, and this is where also Dr. Raj Tilak-Rajan comes into the picture as well, with a lot of his assistants. A fifth goal is to capture images of the lunar surface. And the sixth goal is the scientific goal and objective that we have for the mission, which is to take radiation measurements. We want to measure radiation on the surface of the moon with our rover. And these 6 mission objectives, as long as the more long-term vision that I mentioned before, is actually demonstrated in a vision made in a video. In a video developed by ATG Europe, which I will play right afterwards. One warning only is that the volume might be a bit too high, so just be careful to be ready to lower the volume in that case. And here is the video. As you can see, the rover is deployed while being attached to a lander, as this will be a piggyback mission, joining another major mission to the moon, basically. And of course, the batteries will be charged using the solar panel that we have. Nominal procedures are starting in the operations of the mission. And here is where the obstacle detection, navigation, and navigation in general comes into play, as you can see, because the rover is going to determine which obstacles it needs to avoid and how to avoid them to reach to its final goal. Of course, the scientific measurements as well, while measuring radiation, the surface of the moon, and communicating back to the Earth. Which you can see the Earth is flipped there because the current goal is to be on the south pole of the moon. And this section of the video gives more information about the long-term goals. After the first lunar mission that we intend to participate in, we want to explore other topics, such as swarming, which you can see here, and its implementation, of course. Also, while using a swarm, it is technically possible to make radio astronomy measurements. So basically, this is the information, this is the vision that we have currently for the Lunar mission that we are currently designing and preparing for. But another important field which we are currently developing on is the terrestrial rovers. And the reason for that, one may ask, why would you need to develop terrestrial rovers when you are actually designing for a space mission? Well, there is a need to be able to test the various algorithms with a low risk and low cost, of course, instead of testing in actually space grade or close to space grade materials and structures, as well as to be able to demonstrate these novel algorithms in various occasions, such as conferences, events, PR events, and whatnot. So there is a need to be able to develop a platform of lower cost compared to the Lunar platform, and a platform that is able to implement different algorithms and to demonstrate them. And this is the reason why we actually came up with TRACY, which stands for Terrestrial Rovers with AI Compatibility, which is also part. AI is also a major part of the algorithm demonstration topic that we want to explore with these rovers. Which, in more particular, on the right hand side, you see like rovers that were developed before the terrestrial rovers, which were developed before the idealization of and like the concepting of TRACY, before we came up with this idea, basically, which were really like quick fix rovers. But now we intend to move towards a more well-designed platform, which you can see on the left, and to be able to develop this platform basically more systematically and more in a more system engineering sense, if I could dare to say that. More about the testing side of these terrestrial rovers. Here you can see the path planning in action. This actually took place a couple of, I think, if I'm not mistaken, 1 or 1.5 years ago in one of the test beds using one of the terrestrial rovers. And here you can see the demonstration and testing of path planning algorithm developed by a thesis student. Yes, basically this demonstrates the concept in general and why we are currently developing further iterations on this terrestrial rover. And more particular, some words also which I kept, which were mentioned by Jason James, the project manager basically of the project of TRACY, is that the terrestrial robotics platform has proven invaluable for lunar rover development already. So our current goals is to solidify and standardize these robots within the project for future students and researchers to use and improve the TRL for lunar science payloads in general. So this also has more applications in the future as well for the development of similar concepts. And apart, of course, of the, in particular, the projects in general, and the projects in general, I'd like to give you also some timeline for the project itself. We started in 2013 in particular, when Zebro simply started as an idea, as a concept in a systems and control project of TU Delft, and the locomotion algorithm starting being developed then. Fast forward to 2017, Lunar Zebro as an idea was created. So the Lunar application of this locomotion concept was somebody came up basically with the idea of implementing the locomotion, this locomotion concept on the surface of the moon, and this person was Professor Chris Verhoeven, the project director of the current project. And the design for the Moon rover in particular started then. Then in 2018, the first engineering model was created, the Moon mission was defined, and of course the first rover model was built. And then in 2022, the first development model was made, where testing started, with testing subsystems, testing different assemblies, etc. And this is the last milestone that we achieved, because currently we are continuing this development and trying to push the boundaries and try to meet the requirements to say that we are able to send this rover to the moon, basically. And last but not least, a few words about our team. We are in a team of 67 students, coming from 5 different faculties of TU Delft, and working towards achieving the goals that we have set for ourselves. So basically, that's it. Thank you for your attention. You can always scan the QR code on your right to find out more information about our project. Follow us on our socials. And I'm waiting for questions if you have any.
Yeah, thank you so much for your presentation, Giannis. I really like the video demonstration of the rover on the moon. It was really genius design. Was very interesting to see. So right now, I would encourage our viewers to put their questions in the stream chat. And in the meantime, while we are waiting for questions, if there are any, I have a couple of questions too as a Q&A. We know that you are a master's student right now studying aerospace engineering. We would love to hear more about have you decided that's something you want to do, and what you've been focusing on in your academic journey, specifically in aerospace.
Personally, in the master's, my focus is more on the space engineering side, let's say, more systems engineering, how to be able to design a subsystem, a system, apologies, and the subsystems, as well as with a focus on controls, because it's a personal favorite of mine. But just as a disclaimer, this is not exactly the implementation that I did for this year on Zebro, because of I need to be more focused on the administrative tasks of the student team.
And how did you decide you want to do something like space engineering?
That's a good question. Well, I didn't start with this idea. In fact, in the start, when I first started my bachelor's, I wanted just to do mechanical engineering. I didn't know where to specialize in particular, but I saw that TU Delft had an interesting aerospace engineering program, which was close enough to my interests, and I applied. I participated. I graduated in 3 years, and throughout the course of these 3 years of participating in different subjects of space engineering and aeronautical engineering, I found out that space engineering is more of my favorite, because of its intricacies, complexities, as well as the exploration that we can aid using these technologies, basically.
And you also talked about sending a rover to the moon. So could you tell us more about why do you think it's important to have rovers on the moon?
Yeah, in a more general sense, we have already sent rovers of various natures as well as human to the surface of the moon, but there are inherent risks with sending humans in space in general, and in more particular on the surface of the moon. So we want, as we also showed in the end of the video, we want to establish a human collaboration, human / rover collaboration to minimize the risk of sending a human on the surface of the moon, and as well as to aid in the exploration in general. So to be able to send a probe, send something further away and in a more risky environment, without having to risk, of course, the lives of humans, as well as achieving not only minimizing the risk, but also reaching out further and doing stuff that just human would not be able to do with astronauts. This is in a more generic fashion what the goal is, which is implemented with various future applications which we demonstrated, such as which were demonstrated in the video mainly, such as, of course, the like using the rover for mapping, for sensing on the surface of the moon, as well as creating an antenna, an array, actually, with rovers. All of these are topics that could be developed in the future, given that we demonstrate that it is possible to send at least one rover on the surface of the moon.
And now we actually have a question from our viewers. The question is, which material do you consider for the wheels of the rover?
For material for what?
Which material do you consider for the wheels of the rover?
For the wheels?
Yeah.
Currently, like, of course, it's a metal alloy, like, currently with aluminum. And, like, of course, the characteristics, of course, we wanted to have like a aerospace grade, space grade aluminum in particular, which can withstand the temperature gradients and all for traveling to the moon and being able to maneuver around or over lunar regolith and rocks. Like, currently, the choice is an aluminum alloy.
Amazing. And we just still have time, so I think the last question would be, how do you see the future of space exploration? Do you think people will create space habitats? And what your opinion is on the next 20 years of space exploration?
For the next 20 years, I mean, of course, there is already a trend of creating and supporting life and life presence on the surface of the moon. So definitely there is going to be some kind of established human presence on the surface of the moon. I would say both for scientific but also for touristic purposes, as it is quite a hot, if I could say, trend currently, space tourism in general. And currently, the idea where also Zebro comes into the picture is that these human settlements will need support, and they will need. We will have to study the environment before actually being able to safely host human on the surface of the moon for long periods of time. And this could actually be. I could give some proof of that. I don't have a related graph currently, but I could tell you that. This is an interesting fact that was brought up by another member of management, apart from Raz, of course, Dr. Alessandra Menicucci. She was showing us a graph where the major solar events were shown with really high amounts of radiation, and on top of it, like on the timeline, on top of it, the Apollo missions were shown, like the points where the Apollo missions happened. And I can tell you that in particular occasions, the astronauts of the Apollo missions were extremely lucky because they either arrived just after or arrived just before really major solar events, solar activity, intense solar activity, if I could phrase it more correctly. Which, in case it happened on the point where the astronauts would arrive on the moon, which it didn't, but they were really lucky for that. They didn't expect it. It would have proven fatal for them. So there is truly a need to study these events, study the effects of these events on the surface of the moon, to be able to say with a certainty that we are able to establish human presence with with a low risk of such fatalities, because this would prove a disaster if it would happen again, and if it actually would happen in general in the future. So yeah, I would say increased human presence definitely, and also increased efforts to try to study the effects of radiation and the space environment on the surface of the moon, for sure.
Thank you, Giannis, for being here with us today. We wish you a lot of luck in your further studies and also on this project, Lunar
Thank you.
Daniel. And right now we're gonna take a brief break that's gonna last a couple of minutes before we welcome our next speaker. Thank you so much, everyone. Hi everyone, welcome back to our stream. And now we will have Lasse Hassen present about lunar surface mobility. So Lasse, could you please go ahead and introduce yourself? Thank you.
So yeah, thanks all for the small introduction. My name is Lasse Hansen. I work as a development engineer for PTS, which is the short form for Planetary Transportation Systems. And today, together with Neurospace, we host this event from our site in Rostock-Lage, which is an analog test facility, which has the aim to mimic the moon. And since we as a company get asked quite often, why do you need such a facility and what do you do with it? I decided to give a small speech about, from my opinion, the importance of lunar surface mobility and how to prepare good lunar surface mobility on Earth already. So to just underline a little bit where we come from and what the importance of that surface mobility is, I took a dive into history. All of you know these pictures probably. So this is from the Apollo 11 mission. And the interesting thing here is the first EVA activity actually started with astronauts walking by foot. So the overall distance covered is around 500 meters and not more. And there, and there there's somebody entering. Keep cutting foot. Okay. Sorry, there was somebody entering the room. So the overall distance was 500 meters. And if you quickly noticed that you get more scientific outreach and more scientific gatherings by expanding the distance. So the second stage of lunar surface mobility back then was to have a hand wagon, which the astronauts could carry with them, where they had all their tools and collect samples and stuff like that. So that enhanced the overall distance already to around 2.7 kilometers. But you still needed to do that by foot. So that was exhausting. And the next thing, also something you guys probably know already. Sorry, I took the wrong direction. The next thing, which back then the Congress said is necessary to secure further funding for the Apollo 15 to 17 mission, was the development of the Lunar Roving Vehicle, short LRV. This is a significant step in distance covered on the moon surface. So, for example, from the Apollo 14 to the Apollo 15 mission, you had a difference of around 23 kilometers covered, which is actually a lot. So there you found different type of soils, different type of terrain, which before that wasn't even discovered. So you can clearly see there's a bigger value in covering more distance on the moon surface. This led to the final mission, Apollo 17, with a distance covered of 36 kilometers, which is the longest human traversed distance on the moon so far. And what we did is, because we saw that there's a need for surface mobility, there's a need to test things before going to the moon, we developed a little analog test bed. So here's a short video. So I just wanted to quickly show what we built. As you can see, also we have a longer history with Neurospace. We do a lot of stuff together, and they were one of our very first customers in this test site. So the main idea is you bring your system to our site, and you essentially can check and verify that your hardware is tackling the harsh conditions. I mean, some of them were mentioned already. But especially dust is a problem, thermal behavior of regolith, generally moving and power consumption, the power budget, all of these things need to be really narrowed down to enhance your mission overall. So what we did is, just to give you some rough numbers, we took 40,000 kilograms of that scientific lunar simulant and distributed it in an area over 17 times 5 meters with a depth of 40 centimeters. Yeah, it gives enough coverage for all thermomechanical experiments and ISRU experiments. We also try to simulate lunar lighting conditions, added a mobile gantry for gravity offload to make your system lighter. And that way you can get as close to the lunar conditions as you typically can on Earth. And we also offer this to other customers with the idea that essentially you can book slots faster than needing scientific reasoning why you need to test in our site. So essentially you can just book a day and you're good to go. And what we do in that testbed on our own, I brought some videos here. Mainly later on is some thermomechanical experiments for now. We have a single wheel testbed, a small one, which essentially allows to track power consumption of wheels moving in regolith. There we check the bulldozing power consumption, which is the compression of regolith due to a wheel being loaded on it. On the right side, we just check traversing power consumption of a simple skid steering system. And that way you can essentially also verify simulations and other stuff, and you can verify your calculations with the stuff happening on Earth. And as you can see already, it gets dusty quite a lot, which brings me to the topics we mainly do scientific research on. This is also a HiveR rover with one of the Neurospace colleagues cleaning the camera lens. And there you can see the dust clouds surrounding him, which is fine for short periods, but gets an issue over a long time. And just to put a dimension on that, alone in the Apollo 12 mission report, there were 62 mentions of lunar dust with a negative connotation. And this was a total EVA duration of roughly 8 hours. So if you think about Artemis missions coming back to the moon surface for months and maybe years, this is definitely a thing you have to consider. The thing was summarized in the Apollo 12 mission report with the sentence, "The dust could present a hazard to crew health, and at least it constitutes a nuisance." And a nuisance in this case typically also means a lot of money, because you have to have operations around dust preventing, you need to clean stuff, which is all the time. You essentially could also do experiments and things like that. So it's really a thing to consider there. What we did, we partnered with a company called Viessmann, which is a German, mainly they do AC systems, but also air filtering, as you can see. And we check different systems, how they perform in these conditions, and maybe apply these technologies to airlocks and other stuff, and also have other ways how to prevent dust and tackle dust-related issues. So this is kind of the broader research topic we focus on. Just to summarize a little bit, as I'm nearly finished, I'm looking forward to your questions. There were a variety of mobility needs on the surface, mainly for scientific explorations, and in the future looking also for cargo and human transportation. This typically means that since the moon is covered in this dusty regolith material, that you really need to test your systems in advance, and even for specifically for long times operation, you need significant amount of testing and verification that your systems are working fine. Mainly dust and missing GNSS signals can cause issues here. The dust also blocks radiators, so it's really it's a big topic. It's a sharp, abrasive material, and you need to narrow or nail down ways how to deal with it. And what we do is we offer this testing capability for customers, as mentioned already. So feel free to reach out to us, and we can discuss test cases and how you can essentially bring your system first to the moon in Rostock Lage and then to the real one. So for that, thanks for your attention, and looking forward to your questions.
Thank you so much for the presentation, Lasse. Right now, I will encourage everyone on the stream to ask the questions in the chat as always. And while we are waiting for more questions from our viewers, I have a couple of questions for you as a part of the Q&A. Actually, we got the first question already, so I will start with those. So the first question is, how long does it take to do the ISRU on the moon?
How long does it take?
Yeah, how long does it take?
So that's mainly dependent on when you need the ISRU. So ISRU is in situ resource utilization. So you try to use the stuff which is on the moon surface already. So yeah, we developed some test cases which mainly focus on creating a carpet out of glass fiber, which is a company doing called FiberCode. So we partnered with them, and that's, for example, typical ISRU case where you take a regolith, you melt it to glass fibers, you create a carpet, and you try to mitigate dust appearing while driving with the system. So you essentially could create a road with this carpet, drive on it, and the dust would be mitigated. So and that's something which can happen in 3 years easily, depending on if there's a need and financing for it.
Amazing. And another question I want to ask you, why do you do the lunar test bed with the company you're working at?
So the main thing is, for us, we developed roving systems in the past, and we knew that there's a need for proper testing, and especially scientific regolith, which is typically expensive, is hard to get. So we had the chance to partner up with the TU Berlin and create a big test bed with scientific regolith. So it's physically and chemically extremely close to the real regolith brought back to the Earth. And yeah, so we saw the need, and mainly for us, but then also decided, okay, we are a company, why not offered for others to have the possibility to test here. So that's the main reason behind it. And also for our own ISRU research, I mentioned in the first question.
Amazing, thank you. And another question, since we still have time, is how do you see the further moon exploration or space exploration going into the future?
So I think we have, which is really nice, we have very concrete pillars to kind of grab on answering the questions. One of them obviously is the Artemis mission record. So we know that at some point there will be a more permanent stay of humans on the moon surface. And for me, that's a really exciting thing. I'm a big moon fan, so to say. So yeah, for me, I'm looking at the near future, so that's how I interpret your question. And for me, it's really nice to see this precursor phase of having mobile robots in a terrain which is very hazardous, very uncommon for humans, where robots essentially prepare the infrastructure and build everything for humans coming back to the surface. And this is something which I have a high interest in, and yeah, where I think is kind of the very, or in the near distant future, this will be the case. And then obviously you have the long-term planning, which I think is really interesting, with going to Mars, using kind of the moon or knowledge gathered on the moon for going to other planetary bodies. So yeah, I think this is just the beginning of a long period of interplanetary exploration, and it's definitely an interesting time to be an engineer in that field.
And can you tell us more why you decided to go into aerospace engineering in the first place? And you also mentioned that you are now doing a PhD, so it's very advanced.
So for me, it was kind of a coincidence. So I always typically liked planes more, and funnily, during my bachelor's, I kind of specialized on numerical solutions for differential equations, and I specified on terramechanics. So which is essentially the interaction of soil with solid bodies. So I thought that's mathematically interesting, and yeah, one of the first applications for it, or very good applications, was developed by a Polish scientist called Becker during the LRV development. which is essentially used for designing the wheels to move on the lunar surface. So that caught my interest, and that's how I decided to go to the space direction. And yeah, then I started working for PTS, which was nice, or is nice, 5 years already. And there I got the opportunity during my master's to further continue research in the field of ISRU, mainly focusing on recycling right now. So what I studied and what's kind of the stuff I do right now is a concept for the Argonaut landing system from ESA. And the idea is to reduce the costs of raw material on the moon surface. So right now, 1 kilogram material is roughly $1 million. So by recycling the material you already brought there, you can save a significant amount of money. And yeah, for me, it's kind of this environmental aspect to not create more space debris, to be able to go to a planetary body and not pollute it as humans have done in the past with Earth. So I think it's kind of a new start to do things the right way. And this is really interesting to me. And this is how I got caught in the field.
Thank you. And another question is, we now see that AI becomes quite widespread, especially in our personal lives, but would also be interested in hearing how it impacts aerospace, or how you think it will impact aerospace in the long run. What are like the challenges of implementing AI, and whether it's already useful now for aerospace, or is it advanced enough for aerospace applications?
So AI is a very broad field. Interestingly enough, we also, as a company, work with AI a lot. And this goes from large language models to simple or simpler neural networks. And I think AI will, and it kind of did change the way humans work. I think it will have a big impact on rapid prototyping because, for example, I'm mainly a mechanical engineer, and for me, understanding kind of, or having an easier entry level to understanding electronics, software development, this is stuff you can do with AI even today. So they are, for example, for my prototypes, I don't need to go to my software engineering colleague because I can rather sit down with a large language model like ChatGPT or Llama and essentially write a preliminary code for testing my stuff without needing to have a real developer sitting next to me. So I think that's a powerful way of prototyping and enhancing your development. It won't change that you need that developer at one point, but I think that's definitely a change in how I work. That's what I noticed. And one thing we did, for example, which is a direct application for AI already, we did a live monitoring of our motor drive. So the main idea is you have an IMU data, which catches the vibrations of the motors, and you let an AI run over that IMU data, and you can check for decreasing performance, mainly seeing in the behavior how impacts in the IMU data are appearing. So you essentially can say, my motor caught regolith, and you kind of get a lifetime for how long it will still run. So that stuff you can already do today, which is really interesting and a good application for AI. And I think this is just 2 small examples, and I think everything in between, there will be a lot of stuff coming, and we will see a lot of AI in our daily life also in the future, not just in aerospace.
And this is the last question. Is what are like the main challenges of working on space exploration and like the projects you're working on?
So we have a variety of challenges. Like, it's not just one challenge. I think the main one for me is that you're working with something which is quite, like, you don't have a real feeling for it. If you think about the moon's surface, you don't have an atmosphere. So typically everything which which is facing the sun, gets super warm, and the other side gets super cold, and you have a temperature difference of 300 degrees. That's something you typically don't think about. And this leads to talking about the LRV, that, for example, they noticed when driving parallel to the sun, that the side which faced the sun got warm and was fine, and the other side, the bearings of the wheel actually froze up, and the wheel stopped spinning. So that's an issue which you don't have on Earth, and you typically don't encounter, and you therefore also typically don't think in that way while doing moon exploration. So you always have this different environment which is completely different. You don't have a feeling for it as a human being, and you need to logically sit down and think about all these small steps and small influences on your system design. And that's even with some experience now. I'm not the most senior engineer, but I think even they can tell you that sometimes they catch smaller stuff which they didn't think about it in the right way in the first iteration, and they have to redo it, and figure out after testing. So I think that's also why testing is still a big thing in space and really important. That's my main challenge, I would say.
Thank you for your answer and for the presentation, for putting in effort. Right now, we will go on a 5-minute break before we welcome the next speaker. And just I want to give the last thank you to Lasse for being here with us today.
No worries.
Welcome back, everyone. Now we have Dr. Markus Schladebach with us. He's a chair of public law, media law, and air and space law at the University of Potsdam. He's also a guest speaker of space law at Technical University of Berlin, and he's a German delegate to the UN Committee on Peaceful Uses of Outer Space. Thank you so much for joining us today, and we are looking forward to hearing to your presentation.
A warm thank you to Neurospace for the invitation to a small speech on the modern issue, the US Artemis Accords, Space Law for the Future. Everyone wants to go to the moon. The Americans, the Chinese, the Europeans, and of course, Neurospace. This is not for tourism, but for economic purposes. The applicable rules of space law are quite old. They essentially date back to the 1960s. At that time, it was not yet known for certain whether humans would actually set foot on the moon. Attempts to create a separate legal basis for the economic use of the moon, e.g., for the extraction of natural resources, were made with the Moon Treaty of 1979, but were ultimately unsuccessful. Only 18 states ratified the Moon Treaty, including no major spacefaring nation. So if you want to carry out research on the moon and mineral resources, you are thrown back to the older UN Outer Space Treaty of 1967. This treaty allows unrestricted exploration of the moon. Research can be carried out anywhere on the moon, and facilities and research stations can be set up for this purpose. But what regulations apply if the great rovers from Neurospace want to take part in mining raw materials on the moon and take on important transportation tasks? We can read in the Outer Space Treaty that any form of appropriation of the lunar surface, including the mineral resources there, is not permitted. This is in line with the community concept of space law, which states that the benefits of outer space should not accrue to one state or one actor alone, but should benefit all states together. For the extraction of mineral resources on the moon, this is a serious obstacle. No state and no private company are going to invest in elaborate technique to distribute finally resources to all other inactive states because of the community idea of space law. That's why the NASA has developed a new catalog of principles for, I cited, cooperation in the civil exploration and use of the moon, Mars, comets, asteroids for peaceful purposes. The so-called Artemis Accords. The recent moon strategy of the United States is the Artemis program, and the Artemis Accords should form the legal basis of all Artemis missions. In a formal perspective, the Artemis Accords look like a new space treaty, and they recommend other states to sign these principles. Until today, 43 states did it. The latest was Armenia. Despite it, the Artemis Accords are not a treaty in terms of international law, because it is not possible to ratify a catalog of principles. In addition, the drafting authority of the Accords are not the United Nations, but with the US, only one state. Furthermore, the Accords are a special form of an invitation to the world of states to join the US plans and to participate on the future missions. However, the Artemis Accords could become a real treaty if one state will bring them into the real responsible international institution, the United Nations Committee on the Peaceful Uses of Outer Space in Vienna. The substantial purpose of these accords is to establish a common vision via a practical set of principles, guidelines, and best practices to enhance the governance of the civil exploration and use of outer space with the attention of advancing the Artemis program. With the program is intended to increase the safety of operations, reduce uncertainty, and promote the sustainable and beneficial use of space for all humankind. And so the Artemis Accords repeat a number of rules of the Outer Space Treaty. For instance, peaceful purposes, emergency assistance, registration of space objects, and preserving outer space heritage. These aspects are all in conformity with the existing space law. But with 3 new principles, the Accords put their feet on new ground. Section 10 foresees that the extraction of space resources does not inherently constitute national appropriation under Article 2 Outer Space Treaty, and that contracts and other legal instruments relating to space resources should be consistent with the treaty. In addition, Section 11 regulates the establishment of safety zones in which nominal operations could reasonably cause harmful interference. From an economic point of view, these provisions are quite understandable. Extraction activities concerning natural resources are only then attractive for private companies if they are legal. That's why the states have to overcome the ban of appropriation. And with Section 10, they try it. In recent academic literature, this new regulation has been evaluated very critical. This would constitute a farewell of the appropriation ban, and with it a farewell of the community principle of space law. The possibility of safety zones causes another point of hard critics. Such zones would open the door for appropriation of individual states and for serious environmental harm. That's why the space law community has reacted very reserved to this idea. Obviously, the governments of 43 states worldwide see no legal problem in Section 10 and 11, but want to save the chance to participate on the Artemis missions, especially from their economic perspective. The consensus of 43 states is a sign that the political will of a higher number of states is quite clear. They want to follow the US and their Artemis Accords. A very important third element in the Accords is the ruling of orbital debris. The states should plan for mitigation of space debris, including the safe, timely, and efficient passivation and disposal of spacecraft at the end of their missions, when appropriate. as part of their mission planning process. In the case of cooperative missions, such plans should explicitly include which states has the primary responsibility for the end of mission planning. Following this section 12, the states commit to limit, to the extent practicable, the generation of new, long-lived, harmful debris released through normal operations, break up in operational or post-missions phases and accidents and conjunctions by taking appropriate measures. This provision is a big step forward in space law history. Typically, most of the spacefaring nations deny their responsibility for the reduction of space debris. In the last decades, they argue very often that there is no real problem pressure and the removal of debris is too expensive. That's why a number of activities to regulate these important questions have failed in past. Insofar, the drafting of such a norm concerning space debris is modern and far-sighted. The cleaning of space is, on one hand, a real challenge for mankind, but it is quite more. To use the space for economical purposes, it is necessary to organize free and safe space traffic routes. No enterprise is interested to face the danger of a collision with space debris. For these reasons, the removal of space debris touches also economic interest of private spaceflight. Against this background, it is very interesting to underline that the famous company PTS Rostock Lage works on the idea to transport space debris to the moon and tries to recycle there such debris pieces and to use the materials obtained for new spaceflight projects. What a creative idea! In a short evaluation of the Artemis Accords, we can see light and shadow. There is an urgent need to discuss the rules of the Accords in the signatory states in more detail, intensively and a little critical. In general, the Artemis Accords form a suitable basis for the support of private spaceflight. As we all know, the times of public spaceflight with public agencies are shrinking. There is a fundamental change to private organized spaceflight missions. For these activities of a growing new space economy, the drafted rules are helpful and supportive. On the other hand, it could become a problem not to sign the Accords. If an ambitious spacefaring nation stay away from the Accords, then the state may be lost the chance to be part of the US Artemis missions to Moon and to Mars. Insofar, there is more or less a certain pressure in the process. Bring the Accords into legal effect, it is necessary to transfer this catalogue of principles to the real responsible institution. That is the UN Committee on the Peaceful Uses of Outer Space in Vienna. But typically, this institution needs always a long time for their decisions. It seems to be very realistic that moon activities will operate very much earlier. In my opinion, technique branch will probably not wait for the new rules. Thank you for your attention and have an interesting Moon Day with Neurospace.
Thank you so much, Marcus. Really appreciate it. Just had like one question for you as a part of Q&A. How do you think those space laws will develop going into the future? And do you think that Artemis Accords will just be developed collectively, or there will be like a single body representative that will take care of developing those laws and rules going forward, as of course the space exploration becomes more widespread into the future? Would love to hear your opinion on that.
Yeah. In my eyes, the US will wait for, I think, 1 or 2 years and then bring the Artemis Accords with a more number of states, maybe 60 or 70 states, into the UN Corpus in Vienna and say, we take these accords as a new moon treaty. And the chances, in my eyes, are very good to do this because we have such a consensus in the spacefaring nations. And in my eyes, they will accept the accords as a new moon treaty. And that's why I think they will do it in these real responsible institutions. Yeah.
Amazing. Thank you for joining us. And thank you for your very interesting presentation about how the space laws were created and how they're being pulled and what the space laws are in general, because I think it's a very interesting topic that very few people actually know about. So thank you for that, and thank you for your time joining us today. Really appreciate it.
Okay. Yeah. Thank you and have a good day in Rostock Lage. All the best and thank you for the invitation. Bye bye.
Of course. Bye. So right now we will be streaming the International Moon Day organized by our partners. We will start the stream in 10 minutes from this account. Stay tuned.
there are two main events this 2024 IMD, and one just passed, and Dr. Nasr was in Harbin, and this is the second main event in Rostock, Germany. And the theme for this event for Rostock, Germany is the Moon Village of 2050, exploring lunar mobility. I would like to share our slide, and here you see that several logos are presented. You will see the International Moon Day logo on your left, and the Moon Village Association on the right top. The founding sponsor is Lockheed Martin, and the host for this particular event is Neurospace, based in Rostock, Germany. I have a couple of slides to share with you as an introduction, and then we will move on into the program. The University of Southern California, where I work, has a long association with the moon. Neil Armstrong was a student here when he was assigned command of the Apollo 11 mission. You're looking at his thesis on the screen. We have a larger than life sculpture of Neil Armstrong made by John Hare, and we tend to gather around him during special events dealing with the Apollo 11 project. And I'm also notorious for being a co-author of the Moon book, Resources, Future Development, and Settlement. And the third edition is in the works. Buzz Aldrin wrote the foreword, and Buzz is with us here in Southern California, headed off to San Diego this evening, and all of us will be in tow there. What do I do at USC? I teach in two schools, one in the School of Engineering, in a small but very selective department of astronautical engineering. And here you will see the groups that gather for the finals. We have people from all over the world and from all walks of life, folks. Professors, doctors, lawyers, cinematographers, and a whole bunch of alum who come to watch the finals. Our astronautical engineering department is small, it's very selective, and has been growing, though, in the past few years. We have a global, not only global audience, but a global studentship as well. And we do mostly works. In fact, all of our works are in astronautical engineering as opposed to aerospace engineering. To tell you what the difference is, I would recommend that you take a look at the USC curriculum, and if it fits you, I would recommend you come to class. Take a look at our my studio is based in this department, and if you take a look at what we do, which is what we call the pre-formulations phase of a design, the plan is very simply to get new ideas rolling. And I tell our students that your job is to quickly come up with an idea and not worry about the engineering. We'll take care of that later. In the following semester, I will go back to the School of Architecture, where again, they quiz you with some very hard ground-to-earth topics. The question they ask is, what are you doing for the billions of people on planet Earth? With that, I would like to welcome all of you to the program here. Our first introduction will be from none other than Irene Selvanathan, who is in fact the CEO of Neurospace. And as you know, their company is hosting this event. Thank you, Irene. I will give your bio when you have your talk, but please go ahead with the introduction now. Your mic.
I hope you can hear me.
Okay.
Yes, thank you. Thank you very much for having us there. I'm Irene. I'm the founder and CEO of Neurospace. And yes, we are here in Berlin. We are based in Berlin, in Germany. We founded 4 years ago with, yes, we have all space background. We worked in new space companies. So most of my teams, we had experience of building CubeSats, of building launch equipment. And so we wanted to go in different direction, like having something new, the next version of space. And we decided to go with space exploration. So we decided to go with the moon. And now we are here. We have developed our rovers, which are named HiveR from a hive. And our idea is, of course, to explore the moon and to make it as fast as possible. So we are very proud that we came within these few years so far. And now to be one of the main presenter of this event. So thank you very much for having us here.
You're very welcome. You will get to do your presentation. I think you are third in the row. Thank you, Irene. We are looking forward to your presentation because, as I mentioned, I looked at our site. It's very exciting indeed and very, very creative. With that, shall we go to our next recording Glatki, and I think that is from Dr. Giuseppe Reibaldi. He is the president of the Moon Village Association and has worked at the European Space Agency and particularly on the International Space Station at NASA. And he's a graduate of La Sapienza University in Rome. Could you roll his greetings, Glatki?
So good morning, good afternoon, and good evening to everyone. I am Giuseppe Reibaldi, and I'm the president of the Moon Village Association. Let me first of all thank all the organizers around the world for being part of the International Moon Day and for all the events that they are organizing. The Moon Village Association is an NGO which is registered in Vienna in 2017 and is acting as a unique platform to bring together space agency, government, industry representative, academia, international organization, and the public to discuss and conduct peaceful lunar exploration and utilization. It is a unique organization, and we had developing several activities, which is ranging from technical to economic, as well as to culture. But many details can be seen on the MVA website. MVA is also a permanent observer at the United Nations COPOS, and in that respect has an important function and has given strong, important contribution. And one of these contributions is the proposal to set up, create the International Moon Day. And this has been approved in a very fast way from the General Assembly in 2021. So detail of the International Moon Day and a team, as well as all other information related to the International Moon Day, will be delivered by the chairman of the International Moon Day, Dr. Nasr Alsahhaf. So I just want to take this opportunity to thank all the participants of this event. It's important that once a year, at least, people from all the world take the time to discuss within themselves and with the public what does it mean going forward to the moon, and what does it mean for humanity to harvest resources of the moon in a fair and sustainable way. Thank you, and I wish all of you a happy International Moon Day.
Thank you to Dr. Giuseppe. Our next speaker is none other than Dr. Nasr Alsahhaf, whom I've known for many years. And Nasr holds, he is unique in that he has hopped from different disciplines over the years, spent many years in different aspects of science and engineering. And he was a director of the Geodesy Satellite Center in the Kingdom of Saudi Arabia, and now is a consultant to the kingdom. Nasr spent just a little while ago addressing the IMD in Harbin, and is with us right now. Nasr, the screen is yours.
Thank you. Welcome, everybody, and good evening, good afternoon, and good morning, wherever you may be in this world. And welcome to the 3rd International Moon Day. We look forward to sharing with you a brief history about the International Moon Day, its origins, and its past, brief past, and also our future. So there's an outline here. So if we have the outline, if we can share it, Glavki. So can you share the screen? Yes, thank you. All right, we'll go to the next slide. Okay. We'll start with we have several slides here, I think about 15 or 13 slides. So we'll go in directly to the goals of the IMD celebration. The goals are basically, I'm sorry, let's start with the origins. Yes, I'm sorry, I missed this one. The origins, the United Nations General Assembly 76th session on December 9th, 2021, declares the International Moon Day to be observed annually every 20th of July. So immediately within the next 6 months, we had to put together a whole team and actually have the first International Moon Day, the inaugural one. But first, the goals for the IMD celebration. Public awareness and promotion is very important because we want the youth especially to be aware of what's going on. And in these years, a lot of things are happening since the discovery of what scientists believe to be water since 2017. And so now we have about 20 nations all trying to reach the moon by 2030. Another goal is sustainability in the moon. Once we get back to the moon this time, hopefully it's going to be in a sustainable manner for exploration and utilization of the moon and its minerals. And of course, what's more important is global cooperation and international stakeholders. Going to the moon once or twice might be a feat that any nation can do, but going there to stay and to thrive there and to build laboratories and to cooperate, that takes a lot of effort, and it takes a lot of coordination and goodwill, most importantly, by different nations. Let's go to the next slide. As I was saying, our inaugural celebration was at the Drake State Community and Technical College in Huntsville, Alabama. And that was very, very well done. And it was our first foray into this. And we had about 23 countries celebrating at the same time with us. Next. Last year, we have the second International Moon Day in the National Science Museum in Gwacheon, Korea. And the important thing is that we had an increase of 55% of the number of countries that were part of the celebration. So we went from 23 nations to 41. So that was great, all in a matter of 1 year. And that was very powerful for the kids, for the young students in different schools and different programs. Like I said, in the past main events, we had in 23 and in 22. And this year, we have the main event in Harbin, China, and at the also in the International Moon Day in Rostock, Germany. So we have, for the first time, 2 main events coinciding on the same day, just a few hours different. That's why I'm sorry I couldn't be there with you, Madhu, but it would have had to be faster than the speed of sound. It had to be maybe the speed of light for me to be able to be in both. So maybe next time. We have a different theme every year. So we started in 22 with the Lunar Exploration, Coordination, and Sustainability in Huntsville, Alabama. And then last year we had it as a beginning, the new lunar journey for humanity. And this year it's a nod to exploration. So we thought one of the themes should be illuminating the shadows. And you can use that as different exploration, whether you're exploring for water in the South Pole of the moon, or trying to understand where the minerals are and how to get to them. And so it's basically a play on words where you can be exploring everything. Like I said, in 23, last year we had 41 participating countries, the year before 23 participating countries. And this year we have the IMD Global Events calendar or map showing roughly 40 events, probably by now 40 events, or in 40 countries. So basically we did not increase this year. However, it's more consolidated, so we are on a good track. And it's more widespread this year too. So we're looking forward for next year to even, I hate to say double that number, but at least an increase from that number. This year, what's important also is that we have the telerobotics experience where you are right now in Rostock, Germany, is one of them, Neurospace. And I believe this is one of the activities that is extremely popular with the students, where they actually can maneuver a rover halfway around the world, or in some cases all around the world. And so I think this will, every year I've seen this starting from just 2 countries. Now I think up to 15 countries are joining. Last year we had several countries also. So this is obviously something that will stay with us every year. as it's becoming very popular and it's a hands-on experience. Well, I would invite you to look at our IMD 2024 annual report. It's coming this September, and you'll find it on our website, www.internationalmoonday.org. So please bear with us and follow us. And finally, thank you so much for giving us this opportunity to explain about the International Moon Day. And let's hope that this is an invitation for you for next year. If you have not joined us this year, to join us next year. And if you have joined us this year, please do it again in your areas. That'll be great. So the more, the merrier, and God bless.
Thank you. Thank you, Nasr. It's wonderful to see the growth of the of IMD over the last few years under your leadership, and you are probably one of the most understated chairpersons I know. But it's always been a delight to have you, to discuss with you, and keep in touch with you, Nasr. Thank you. So now we are off to our next presenter, who is again Irene Selvanathan, who is the CEO of Neurospace. And Irene has a scientific background in the field of gallium nitride electronics through work at the renowned Semiconductor Research Institute, Ferdinand Braun Institute, and Leibniz Institute. I know that one. And she completed her studies in electrical engineering at the Technical University in Berlin. Please welcome Irene to talk about creative pursuits.
Hello, and thank you. Thank you once more. I will then just share a presentation, about what we are currently doing. And so, sorry, I need to enlarge that.
Are you able to go full screen, Irene?
Yes, I'm about. So,
Perfect.
so now it's going.
Okay.
So our approach was to create low-cost lunar robotics. This was what we have taken from the CubeSat technology, because CubeSat is actually those which has created new space with this approach, with standardization, low-cost technology. And so our idea was that this can be adapted also for space resources, for space exploration, for rovers. And so this is the idea. But and so, yes, of course, I want to introduce my team as well. And this is I have a great team with very huge experience from very diverse backgrounds, and they made this all happen, and I want to thank them a lot. So, of course, the core team is my tech team, and then we have a lot of people from business also. So what we were actually thinking about was where does space go to? What is the idea of space exploration? But therefore, we had to look at the history and figured out that there is this huge difference, because during Apollo mission, we have counted a number of missions going on within roughly 40 years, but it was very political. During the Cold War, a lot of money was spent and a lot of risk was taken. But yes, it has another approach. We can still say it's still political, but with a huge interest of industry. So within the 2000 and 2021, not much happened. But the numbers of participants, the countries, were increasing slightly, but it was still not very commercial. and then came up from 2022 to 2030. Within 8 years, it was like explosion. So there was a kind of huge interest from many countries. And this is because from what was going on from the 20s on, from 2000 on. So I think CubeSat have shown that space was affordable for many countries due to this new space approach, using COTS components or different way of applying technology. And that's what we guess was also building ability for different countries who didn't have this kind of space program still to participate, which is great because this is democratization of space, actually. With this impact, we saw a very great possibility. So that's why we have looked up also still in history what happened. We found the Lunar HOTS, the Russian rover in the 1970s with very great technology, which is still being used. Like, for example, the solar panels, the radiation heat plate, the systems, the sensors, the camera systems, and it worked very well. So we also went further, for example, Sojourner, a very small version of a rover, which was on Mars, which was compared to other missions, very low-cost rovers, to $25 million. And it still reached a great travel distance. It has this rocker bogie chassis, which has been used up to now. It has the 6 wheels, which we really liked. And then, of course, the Chinese mission with U2. And this was also something which encouraged people then also to do more in this direction. So I don't want to talk too much about the technology. I just want to say that this was the idea which we also took. So we had started very, very slowly and figured out there were so many things which we have to cope with. The challenge, for example, with the Lunar regolith. This was the thing where we thought, okay, this is something totally new to us. Also for space technology, if you deal with CubeSat. So this is where we started. And then we thought we will go slowly to every other step until we reach the right qualification up to Moon. By this way and this approach, we figured out that our rovers are not only made for Lunar, so for the Moon, but that we can easily also adapt it on Earth. So this gave us the chance to also have an early revenue. So we are already selling these Earth application rover, which have very interesting use cases in any way. And with this, I can just introduce you to HiveR. This is how it looks like. So on the top, you can see a very, it's very clear. It's a CubeSat, which has the dimension of 3U. This is just to create the image for the users, what is possible, that maybe the CubeSat technology can be transferred also to rover technology. There are a lot of applications which you can use on Moon. So that it should help also to create ideas. It doesn't mean that we want to take it this way to the Moon, but like this technology. And it should be also very modular. So our idea was that we will deliver what's below the CubeSat and give access to those who manufacture the CubeSat or anything else which comes on the top. So with this, yes, we plan to contact a lot on Earth, a lot of customers on Earth, as well as for the Moon. So the idea was like creating a tiered system, and this is where we are. We already created the economy version, and then we want to go up to reaching the Moon slowly. And just to show more insight, to give more insight where we are, we started very early. We had the idea of this rover, and then we just presented it in a very easy demo proof of concept version. Then we started to implement a rocker chassis in a very easy way, included the differential within the time. I have also made a video where you can see it. And then we have developed our own drive system, and has several reasons why we did it, because we see more. We wanted to not only design something new because, yes, just because we can. We just have several reasons where we think that this might make more sense. One of it is, of course, using it on Earth. This is the usual rocker bogie chassis is not sufficient enough. It's way too slow. It's stable. It's a good system, but you want to have a very great stable system if you want to drive fast on Earth, for example. So we took an approach which we call 4X, an independent drive system. And with this, we did a lot of testing. We tested it also like today on Regolith. We tested it with different angles and see how it reacts on Regolith. And by that, we tried to make the whole mechanical drive system way more easier, which was extremely important. So that we don't have to get too much issues with the mechanics. So it ended up with this, and now we have a very solid system. It's not the one which is being presented here. For the Moon version, we also have developed another system which we just still keep very secretly, but it turned out to be even more simple, but very efficient. This is something which we needed. So yes, we did a lot of testing for all the mechanical parts. By the way, we also developed a tiny little robotic arm, but then we wanted to test it in space. So this is what's coming up. We have two missions. One is with the exploration company. They built, these capsules and want to have it for manned mission. And with them, with their maiden flight, our 12U little box joins their mission from our side, where we test our drive system with the SpaceX rocket. We let the mechanical parts move and drive in 0G. But our first test is already while the rocket gets launched. So we want to see how it survives, how the deployment systems, which holds the mechanism, how they act. And then we want to see how it reacts in 0G, if everything works fine. And then finally we get to fix them once more, and then it gets, the capsule will land back on Earth. And then we can see the impact of the harsh landing while it crashes on the ocean. And then we can, hopefully, if everything goes well, try to find out how it works, if everything has survived, or what happens in these terms, these impacts. So this is what we do. And of course, the next upcoming mission is, and we are very proud of this, is with the NASA Artemis 2, where we are going to test the electronical parts. So where we're going through the radiation belt and see how the impact of radiation is, has an impact on our system. And there we are going to test only the electronical components, the most important parts, and so on. It's a great mission because it's a high altitude orbit. We also test, for example, a fueling system. And yeah, we're very excited about this and being part of this. We have great partners here who are supporting us. And so this will be the Artemis 2. By the way, we also develop all the autonomous drive. We are training our systems, and we even inserted it into a VR area. And yes, we just try to also bring this forward, train our system to get more autonomous. And this is, for example, the usage of our technology, for example, on Earth, in terms of a disaster. If a disaster appears, that you can send out a swarm of robots, robots or robotic systems, and some are equipped, for example, just with communication to just create communication as fast as possible. The other one is with as for search and rescue, to help the search and rescue teams to plan their mission, to find out what's going on before they bring themselves into danger. You can also see the one with the LiDAR system. This creates a kind of situation awareness, a mapping, three-dimensional mapping. We already tested all these things and works great. And then you can also, in addition, equip them with sensors and so on. And can just let them give you back, for example, if there is a leakage of radiation, of toxic gases or whatever, which also should help rescue missions. This is just one example. There are many more, but I want to limit this. So yes, of course, we are very much open, but this is just to give an idea what rovers are made for. And this is just more than just space exploration. So thank you very much.
Thank you, Irene. This is not only opening ideas to creative ideas, but I think there is so much to explore here with these cute little rovers, and we will have questions for you. But I think we're going to run the program, and we'll take some questions in the end. Thank you, Irene.
Thank you very much.
It appears we skipped a part of our program, and we're going to have a recording from some space agencies that Glafke is lining up for us now. Glafke, are we ready?
We are ready.
Distinguished delegates, friends, happy International Moon Day, or should I say Merry Moon Day? I leave it to you to decide. Today we celebrate our closest celestial neighbor, the Moon, and its significance for Earth and humanity. The Moon has been a source of wonder and inspiration throughout human history, playing a vital role in our natural world and in our scientific and technological progress. International Moon Day was declared by the United Nations General Assembly in 2021, and it commemorates the first human landing on the Moon on the 20th of July 1969. It promotes awareness of sustainable lunar exploration, an activity which is becoming more real and a topic which is becoming increasingly important. The Moon's exploration is crucial for scientific discovery and technological advancement, and it will be a stepping stone for humanity's exploration of the stars beyond. UNOOSA recently hosted the first United Nations Conference on Sustainable Lunar Activities in Vienna on the 18th of June. It was a significant occasion that brought together signatories of the Artemis Accords and the International Lunar Research Station, but also member states, NGOs, and the private sector. The conference overwhelmingly demonstrated a growing international consensus on the need for information sharing and coordination in lunar exploration, rather than a space race, which is, of course, where it all started, or indeed a division of space policy. Key takeaways that states prioritized included the importance of transparency and interoperability, the usefulness of dedicated international platforms for consultation among stakeholders, and the deep value of predictability and a proactive approach towards lunar sustainability. It was clear that the Moon is both a driver but also a unifier for scientific exploration. As far back as the 60s, the United Nations member states have been harnessing the convening power of the UN to negotiate the Outer Space Treaty, which states the exploration and use of outer space, including of the Moon and other celestial bodies, shall be carried out for the benefit and in the interests of all countries, irrespective of their degree of economic or scientific development, and shall be the province of all mankind. In 2024, COPUS, the Committee on the Peaceful Uses of Outer Space, is more relevant than ever before. 3 weeks ago, the committee took one giant leap to promote these ideals through the establishment of an action team on lunar consultation. Through the deliberation and negotiation of expert-informed recommendations over the next 2 to 3 years, this action team will enhance global cooperation and coordination in lunar activities. Furthermore, the committee's working group on space resources continues to work on the definition of space resources, and it seems that consensus may be forming around water, ice, and mineral resources, all of which are necessary for deep space exploration and human settlements. It's an exciting time and very real. This is no longer science fiction. On this special day, we also have to celebrate the many achievements of lunar exploration, and I do want to congratulate China on the successful return of its Chang'e 6 mission, which brought back the first ever samples from the far side of the moon. I hope you have a wonderful 3rd International Moon Day Conference in Harbin. From ancient myths to modern science, the moon has always been a source of wonder, and I have no doubt that the work you will do will continue to be a source of wonder in years to come. It is the one thing that each and every one of us on this planet looks up to at night. The moon connects us. I wish you all the best, and I thank you.
Thank you. The moon definitely connects us. We are ready for the State Department talk.
Thank you to the International Moon Day organizers for the opportunity to speak today on the role of diplomacy in our lunar exploration. My name is Valda Vikmanis, and I am the Director of the Office of Space Affairs at the U.S. Department of State. My office oversees civil and commercial space diplomacy on behalf of the U.S. government. Within our portfolio, we negotiate international standards, norms, and legal frameworks at the United Nations and other multilateral organizations to guide the peaceful, responsible, and transparent exploration and utilization of space. We translate these commitments into binding bilateral space agreements with foreign countries that make it easier for NASA, NOAA, and other U.S. agencies to engage in practical research, development, and technical cooperation. We convene regional and bilateral dialogues to exchange views with our close spacefaring partners. We promote the global use of U.S. space-based data, services, and applications like GPS. And we help expand market access for the U.S. space industry and improve foreign regulatory frameworks to ensure safety, transparency, and interoperability. And we create new communities of interest on emerging space issues like the Artemis Accords. Today, I'd like to highlight some of my office's work that's directly relevant to the International Moon Day. My office leads the U.S. delegation to the United Nations Committee on the Peaceful Uses of Outer Space, or COPUOS, the preeminent multilateral forum focused on international cooperation in outer space, as well as the International Committee on GNSS, or ICG, which reports its results to COPUOS. The agenda at COPUOS tackles issues on space resources, the long-term sustainability of space, and connecting space activities with sustainable development. COPUOS continues to demonstrate its value as a forum for helping translate our shared values, like those codified in the 1967 Outer Space Treaty, into best practices for modern space activities, as demonstrated by 2 recent examples. First, the U.S. delegation was pleased to see the consensus adoption of a mandate and terms of reference for the Action Team on Lunar Activities Coordination, or ATLAC, at the COPUOS plenary last month. The Action Team will develop recommendations to improve consultations on lunar activities and will consider options for establishing future international mechanisms. ATLAC's goal of enhancing communications about lunar activities is something the United States wholeheartedly supports. Second, within the International Committee on Global Navigation and Satellite Systems, the United States encourages discussion on coordination related to the use of lunar positioning, navigation, and timing, and just recently held a session devoted to this subject. While these discussions are in the early stages, it's clear that multilateral diplomacy is critical to addressing and resolving compatibility and interoperability issues. As we seek to address the challenges of lunar exploration, we should look to multilateral organizations like COPUOS, ATLAC, and the ICG as examples of how to build consensus toward practical and effective solutions. As NASA prepares to return to the moon through the Artemis program, the State Department's Office of Space Affairs works closely with NASA to co-lead U.S. engagement and outreach on the Artemis Accords, a set of non-binding principles for future civil exploration and use of outer space. These principles will guide the United States and other signatories as we return to the Moon and venture beyond. To date, 43 countries have signed the Artemis Accords, including major spacefaring nations, as well as countries with emerging space programs. A commitment to the Artemis Accords is a commitment to a safe, sustainable, and peaceful space environment, and an invitation to join the discussion on how to best implement the Accords principles. And finally, I want to highlight an exciting future opportunity. The White House-led 2022 National Cislunar Science and Technology Strategy endorsed the concept of an International Lunar Year, modeled on past examples like the International Geophysical Year or the recent International Polar Year. International science years represent what's possible when the best of science meets the best of diplomacy. These scientific years have led to breakthroughs as well as real political achievements, like the creation of new international treaties for Antarctica and outer space. As we look forward to an exciting decade to come of renewed deep space exploration to the Moon and beyond, the time is right for establishing an International Lunar Year before the close of the decade. Across all of these challenges and opportunities, forums like this one help advocate for continued investments in lunar exploration, research, utilization, and sustainability. Because of the International Moon Day, we know this is not just a priority for a small group of advocates, but a shared global endeavor with important cultural and historical impact. Thank you again for the opportunity to speak. Happy International Moon Day, and we look forward to collaborating over the coming years and decades of lunar exploration.
Wonderful. Now we are off to
International Moon Day, celebrated on July 20th, commemorates the historic Apollo 11 mission and humanity's first step on the Moon. It commemorates past achievements in lunar exploration and look forward to raise awareness about Moon significance, as well as inspire future endeavors, promoting international cooperation for sustainable exploration of the Moon. This is more relevant today because globally there is a trend of renewed interest to explore Moon, not only by the government entities, but also from the private players. At this juncture, I acknowledge the contribution of the Moon Village Association for the declaration of the International Moon Day by the United Nations. India has a legacy of lunar exploration, and it is motivated by the spirit of comparative planetology. The Chandrayaan 1 and 2 missions have conducted detailed orbiter-based studies on the Moon. The scientific results from Chandrayaan 1 have revolutionized our lunar science, and discoveries of hydroxyl molecules on the lunar surface indicated hydration, novel views of the interaction of solar wind on the lunar surface indicating by the subsequent mapping of the mini magnetospheres of the Moon, evidences of geologically recent lunar volcanism, to name a few. The Moon Impact Probe, which was piggyback on Chandrayaan 1 mission, has returned significant scientific outcome, especially of the noble gases as well as water vapor in the sunlit lunar exosphere while descending on the lunar surface. The Chandrayaan 2 orbiter was thematically configured to study the lunar surface, subsurface, and exosphere based on the scientific outcome of the Chandrayaan 1 mission. Chandrayaan 2 has several discoveries in its credit, which includes unambiguous detection of the lunar water ice, the global mapping of the lunar exospheric argon-40, the first ever global mapping of the lunar surface, especially with a high resolution, 25 centimeter resolution from the orbital high resolution camera, and also the identification of very, very small features on the lunar surface. Although soft landing could not be achieved in Chandrayaan 2, the orbiter is still functioning and providing a lot of data to us. After the encouraging scientific accomplishment of these two orbiter missions, we had the Chandrayaan 3, which made remarkable and very inspiring landing on August 23rd, 2023, at the southern higher latitude location on the Moon. The landing site, Chandrayaan 3, is named as the Statue Shiv Shakti, And Chandrayaan-3 comprised of 3 modules, the orbital module, the lander, and the rover. Pragyan, which moved almost 101 meters on the moon surface. The scientific experiments were conducted both by the lander, the Vikram, and the rover, the Pragyan, till the local dusk for almost 14 days before the lander and the rover were put to sleep. We were also able to successfully do interesting missions like the HOPE experiments, where the lander engines were once again ignited. And we also made an experiments to bring back the orbiter back to an equal Earth orbit. So the mission objectives of Chandrayaan-3 have been fully accomplished. The data analysis by many scientists are in progress. And we are also working for future series of Chandrayaan missions, where the Chandrayaan-4 at this moment is configured to bring back samples from the moon. And we are also working on future roadmap of Chandrayaan series of missions leading to a landing of a human from India on the moon by 2040. In the global endeavors, we collaborate with many other agencies, especially the one with JAXA for a mission to go to moon called the LUPEX mission, which is to explore the volatiles, including lunar water in the permanently shadowed region of the moon. ISRO has also shared our data from Chandrayaan-2, especially the camera OHRC camera data has been shared by other agencies for them to look at the best site for their landing. And similarly, I would like to congratulate the successful moon missions in the recent times, especially the Japan's SLIM mission, as well as China's Chang'e 6 missions, and look forward to establishing a way to collaborate, cooperate for a sustainable moon study and exploration. I think the contribution by Moon Village Association has been tremendous in rekindling the interest in the moon for all of us, and we like to join with you in celebrating the International Moon Day 2024. Wish you all a great success. Thank you.
Ladies and gentlemen, distinguished guests, thank you for inviting the Egyptian Space Agency to this event. Today, we gather to celebrate the International Moon Day, a significant occasion that honors humanity's achievement in space exploration. One small step for a man, one giant leap for mankind. As we stand today, looking forward at the moon, let us remember that this celestial body has inspired generations across the globe. The moon, with its quiet presence, serves as a beacon of hope and a symbol of our shared aspirations. The International Moon Day celebrates the historic first manned mission to the moon, when for the first time in human history, Neil Armstrong set foot on the moon. This achievement was celebrated worldwide as a success for all humanity. It reminded us that when we set aside our differences, we work together, we can accomplish the impossible. The moon landing was not just a scientific milestone, but a powerful message to ourselves that science and technology has no borders. It is a demonstration that we can believe in ourselves and can contribute to the global arena of innovation and discovery. It encourages us to dream bigger and to reach for the stars together. Space exploration has led to numerous technological advancements that have fostered various aspects of our daily lives, from satellite communications and weather forecasting to medical technologies and environmental monitoring. For developing nations, these achievements have been particularly important. Despite these benefits, developing countries face significant challenges in participating in space exploration. Limited financial resources, technological infrastructure, and expertise are core challenges that cannot be ignored. However, these challenges also present opportunities for collaboration and innovation. International partnerships play a crucial role in this regard. By collaborating with spacefaring nations and international organizations, we can access the necessary resources, share knowledge, and build our capabilities. The United Nations Outer Space Treaty emphasized the importance of peaceful cooperation in space, ensuring that the benefits of space exploration are accessible to all countries, regardless of their level of development. Artemis Accords and the International Lunar Research Station initiatives are major projects that stimulate international collaboration and present a significant leap to the humankind. One of the most profound impacts of space exploration is its ability to inspire and educate. The Moon, landings, and subsequent missions have measured inspiration, curiosity, and passion for science, technology, engineering, and mathematics among young people worldwide. In developing countries, this inspiration is vital for the development of next generations of scientists, engineers, and innovators. As we celebrate International Moon Day, let us look to the future with optimism and determination. The Moon, our nearest celestial neighbor, continues to be a focal point for exploration and discovery. Upcoming missions, both manned and unmanned, promise to unveil new insights about its composition, resources, and potential for supporting human life. For developing countries, this future holds immense potential. By participating in lunar missions and related research, Egypt has signed the RRS agreement through which we are currently developing a lunar camera in collaboration with Bahrain. The lunar camera will help in understanding the topology on the Moon's surface and is expected to be placed on Chang'e 7 mission in 2026. This mission is dedicated for studying Moon's resources such as water, ice, and is expected to contribute towards sustainable space exploration and making space more accessible to all. In conclusion, International Moon Day is a celebration of human imagination, perseverance, and unity. It reminds us that the Moon belongs to all of humanity and that its exploration is a collective endeavor. For developing countries, it's a call to action, a call to embrace the spirit of exploration, to overcome challenges through collaboration, and to invest in education and innovation. Let us honor this day by reaffirming our commitment to peaceful space exploration, by inspiring our youth to dream big, and by working together. Thank you, and I wish you all a wonderful event.
I believe we have one more recording, Blackie.
Yeah, 1 second. It's not working, this link. Can we go on?
Do you want to move the program along, or?
I'll try to make the video work. Just move along until I'll get it to.
Did you want me to wait?
No, go on.
Okay, great. So our next speaker, it appears to me that Carl, is he with us?
No.
Let's take a look here.
Next should be Frank.
Is he here? No. I think we're going to go to Frank Cobb. Frank, we'll go with you, and then if Carl turns up, we will have him follow you.
Okay.
Frank, let me share a one-sentence introduction for you. And to all of you, you're invited to spend a minute introducing yourselves. But Frank is the CEO of Orbital Recycling and holds a physics degree from the beautiful University of Heidelberg. Frank, please go ahead.
Well, thank you so much for the introduction. So orbital recycling, you might later on see a video we are doing, but I can quickly summarize our whole story. We are working on our space debris around Earth. This comes from my background. I studied physics in Heidelberg, as mentioned, which is indeed a very lovely city. And with this background, also from technology and from sustainability areas I worked in the past as well, we brought the topic of a circular economy to space. So the idea is that we want to regain raw materials from space debris, especially aluminium, as the recycling process of aluminium is pretty simple compared to other raw materials, and especially to electronics. And we want to bring this aluminium, the space debris, from its current position in Earth orbit further to the moon, as we think the biggest market for materials would be the construction of a lunar ground station. Like the ISS, a lot of materials needed to build the lunar ground station, shielding materials, airlocks, and so on. While some of this material could be gained directly on the moon, others have to be brought from Earth. And in our case, brought from higher orbits, which dramatically saves energy costs and therefore transfer costs. So our technology is mainly this raw material recycling, aluminium casting, and so on. And this needs, besides space technology, also mobility technology directly on the moon, the topic I'm speaking about. Now, moon exploration actually started as in the same way as we as humans started hundreds of thousands of years ago, right? We walked. We started by exploring our environment by walking around, and this is what the first human on the moon also did, right? They walked around and left this iconic footprint in the moon dust. But similar to Earth, right, we enhanced our technologies. We switched from walking to hand wagons, to hand carts, right, mainly to transport more weight in an easier way. And exactly this happened 10,000 years ago in the past, right, where we developed the wheel, invented the wheel, and then more or less the same happened on the moon as well, right? And then from these hand wagons, we moved further in mobility point of view by using cars on the moon, right? And this drastically enhanced our capability to explore the environment from first few hundred meters by foot. We moved to the hand wagon, it was 2.5 kilometers. And now with the car, we could reach up to 36 kilometers. So we explored a much broader environment and found out more on the moon, right? We could reach further distances. And if you like, the next step was then remote cars to do exploration. A little bit like on Earth, where we are now developing these remote autonomous driving, right? It kind of happened already on Mars and on the moon, where we had these robots exploring the environment, and more or less the next logical step of mobility on the moon. But all these mobility aspects had some problems in common. So what makes mobility on the moon special? Well, of course, the moon itself, right? But from a mobility point of view, mainly the moon dust, among others, of course. But the moon dust is the terrain where mobility actually reacts with. And moon dust, you heard it already today, maybe in other sessions, or you know it by heart so far, is a very fine stone powder. And especially Irene and Neurospace know that this is very, very challenging to drive in this environment, right? And later on from Jim, you might hear ideas what you can do with this by doing also mining and other activities on the moon. But first, we have to solve this problem of how do we actually drive in this area? How do we get forward, and literally forward, in this very severe material? And for this, we developed an own test facility called TheMoon. The moon is in Rostock, and that's where the German Moon Day actually takes place today, thanks to Irene and the organization team from Neurospace. And you see here, this environment has 40 tons of this material. You saw a very initial version of the Neurospace rover driving around. This year, you see the super enhanced version of it. But this is a facility which we from Orbit Recycling also utilize to do our tests, right? To enhance and develop this mobility problems, or work on these mobility problems, so we can really run our own solutions there. As I said, we have roughly 40 tons of scientific artificial moon dust. It spans an area of 17 by 5 meters. And we can also simulate the lighting conditions, which come very close to the moon with a very sharp, bright light to simulate the sunlight. And we can also trick a little bit of this gravity with a mobile gantry. But mainly we use that facility to do these mobility tests. So we could test on the left side different wheel designs, right? As I said, it's these very fine, very sharp stone powder, and you need specific wheels to get forward. You need specific wheels to go upwards of a hill and so on. We can also use this very large environment to test different layouts of the rovers. They can act in swarms or work alone. But the biggest challenge we see with this rover is just driving straight forward. You cannot imagine how complicated it is just to go straight forward without any global navigation system, without any orientation on the moon, right? All you have is your own marks you leave to find out if you're going straight, turn left, turn right. So these tests really, really help us with our own mobility needs and to proceed. But we can also utilize this huge dust environment of the moon in Rostock to test our processes, to test our technology, if they are dust proven or not. Here in the middle, you see a classical air cleaning solution, and this time from Fissmann, a company we work with together. You can imagine that without these cleaners, you have dust everywhere. And just by driving around, you generate dust. And the moon lander will generate a lot of dust. And this actually is the mobility need we have, right? We have a moon lander which brings supply, maybe to astronauts, maybe to robotic systems on the moon. And then the moon lander would generate such a huge amount of dust that it cannot land very closely. So for this, we have to transport this material for a while or for a longer distance on the moon. And this needs to be tested up front and needs to be developed by companies like Neurospace, like OffWorld, like others. We just utilize these kind of solutions. To summarize this very short session on a topic which spans or fills full books, right? And there was just recently released a new report from NASA about mobility needs they have and they see. You can imagine just by looking around how many different mobility solutions we use on Earth for ourselves, right? From bicycles to e-scooters to cars to trucks. And you can imagine that people on the moon will have similar problems, right? They need to bring cargo from one place to the others. They need to transport astronauts from one place to the others, and ideally both from time to time, right? Just bringing astronauts is not very helpful if you can't bring their luggage with them. On the moon, we still have the problems of this dust, and I love to repeat this because over the past 2 years, I only worked with this dust. But there's also no global navigation system on the moon right now. So how do you navigate on the moon? It is completely different and very complex. As I said, sometimes you just look at your own prints you leave in the regolith just to find out if you're still going straight. And then the lighting condition complicates the situation as well. The regolith is really something you have to test. And even if you think you have sealed your rover, you drive around for a full day and then you open up your box, and by surprise, you will find easily 1 kilogram of regolith because it can sneak in everywhere. We do our tests here in Rostock at TheMoon. It's offered by PTS to all companies around the world. With clear focus of Europe, just from a location point of view. Customers from Germany, Luxembourg, South Africa, and Turkey already utilized this facility. Orbit Recycling is a happy user of that facility as well. And from that point of view, I can only encourage you to take a look, especially later on when Irene and Neurospace show what their rover can do and how they behave. With this, I would love to end my short overview about the mobility needs on the moon. A very, very short overview of what orbit recycling is working on. The topic of space debris recycling is really exciting from that point of view. If you have questions, feel free to send me an email, ask questions in the chat whenever you like. It's a topic of its own, but not for today. Thank you so much for your attention.
Thank you, Frank. Very interesting. And it is always, there are so many questions you pose when you do these type of simulations. But as Goethe mentions, there is magic in beginnings. Thank you very much, Frank. And now is Carl showing up on our participants? Not yet, right, Glavke? And I know that Professor Heinz Hubers is not with us either. Irene, do you know? I get the impression you know Frank, and from the demonstration videos I see, you've operated on the moon. The moon simulator. Now, Glavke, shall I go to our next presenter, or would you like? Have you figured out how to run the recording?
Let's play the video.
Okay, let's do it.
Hello, everyone. I'm Shuayong, Vice President of Harbin Institute of Technology, China. It's a great honor to join you all in celebrating this significant occasion, the third International Moon Day. We have just concluded a very successful International Moon Day main event here in Harbin. First and foremost, on behalf of Harbin Institute of Technology, one of the organizing bodies, I extend my heartfelt gratitude to the Moon Village Association, the Chinese Society of Astronautics, and the Chinese Society of Space Science for their invaluable support in making the International Moon Day 2024 event in Harbin a success. In 2022, the United Nations declared July 20 as the International Moon Day, commemorating the anniversary of the first landing by humans on the moon. And the day is also intended to raise public awareness of sustainable moon exploration and utilization for the betterment of all humankind. During our main event, we showcased the winning interest from the Moon-based 2015 Global Innovation Competitions, hosted the Lunar Village Science Forum, and organized various other activities. Move forward, we will continue to focus on innovation and sustainable development in lunar exploration, aiming to usher in a new era in human exploration of the moon. HIT is one of the most valued universities in the field of astronautics in China. For many years, we have been dedicated to promoting international cooperation in astronautics education and have built strong collaborative relationships with the university around the world. Dear colleagues, let us continue to embrace globalization, enhance the international cooperation in the field of astronautics, and work together to advance lunar exploration. Together, we can realize the inspiring vision of a future lunar village for our humanity. Finally, I extend my best wish for a successful International Moon Days 2024 event in Rostock, Germany. Happy International Moon Days. Thank you.
That was wonderful. The thing about the Moon Village Association, I would always tell our good President Giuseppe that we are able to bring the whole world together, Nasr. And it is wonderful to see this because nations by themselves are unable to do what the Moon Village Association is doing today. And I'm so glad that we are all part of this this effort to bring the globe of nations together to realize that the moon is a global ambassador and that we can play a little part in a peaceful collaboration in outer space. Thank you for that recording. And Nasr, did you meet him in Arvin?
Yes, absolutely. I had the pleasure to meet the whole team, the whole crew. Excellent people. Wonderful.
Great, thank you. So now we have two no-shows. I'm sorry that Carl Stollers and Professor Hubers, they cannot be with us. Irene, do you know them?
Yes, they are not able to speak today. Okay. I'm sorry.
Okay, yeah, I got the impression that you're all connected because of the work that you do. So we are off to our speaker, Jim Caravalla, whom I've known also for many years. In case you're wondering, folks, we are a small mafia here, many of us having gone to the same schools, attended the same conferences and meetings. Nasr and I are part of the 1988 batch of the International Space University. And I think I remember seeing Jim in 1989 in Strasbourg. But then I think he was just testing the waters, whether it was interesting to do this. And then he went on to do the ISU later on. But looking at his bio, I get the impression he has spent time in different schools, both in the UK and in the US. And what comes to mind is Surrey, which is an established school for developing satellites in the UK. And then he spent some time at MIT. And Jim is now the CEO of OffWorld, a very creative and I would say a brave pursuit. He is a few light years ahead of the competition because he has been at it from the idea of for-profit motives and doing very well. And he has got himself into the mining industry. And I hope to hear more from you, Jim. Go ahead and do what you will for us.
Thanks, Madhu. Thanks, everyone. Good to see everyone. And I really enjoyed the presentations so far. And hope everyone's having a great International Moon Day today. And thank you, Nasr, also for your leadership for this great annual event. So if I was to share my screen here, Hopefully you can see that well enough.
Yes, we can.
Very good. So let me then spend a few minutes just going over what the present offers, what the future holds, and where our destiny takes us. So one thing is very clear. We are a generation that is facing the potential existential responsibility of humanity. 1,000 generations that have come to pass and 1,000 generations before us are dependent on us in this great pivot point in history. We are reaching a point where the resources of planet Earth may well be approaching certain limits. Our ability to overcome those limits, improve the way we live, the way we do things, and rebalance the planet so that growth for our civilization in generations to come is sustainable, that we thrive, that we're not facing energy, mineral, food, or water shortages, are all dependent, absolutely dependent, on us successfully scaling expansion into the cosmos. The resources of space, both energy and matter, are absolutely essential to improve life on Earth. There is no alternative. We cannot fix a closed system from within the system. It's like trying to grab your shoelaces and pull your boots up off the ground without any external help. We need an external frame of reference. Space is our home. Our planet is in our home of space. But the nursery of where we are on this planet needs to expand out. And so the opportunities and the bounty of harvesting in the solar system are extraordinary. There are so many mineral resources. There is unlimited stable energy for at least 900 million years, long enough for any investor to make a good bet on. And the opportunities for us to have hundreds of billions of people alive into the next century or two is really at our fingertips this decade and this generation. How we go forward now, the values and principles that we build, the culture and the methodologies and the codes that we operate by to support one another is going to be critical. How we establish culture and community in space so that we can address the resources of the asteroid belt, the near-Earth asteroids, and the moon is going to be critical. So we have all of this opportunity at our fingertips. And OffWorld has been developing over the last decade to support humanity in the harvesting and gathering of those resources to build for in-space operations. So we are building a multi-planetary and celestial body mining architecture that can expand into construction and infrastructure development. The principles that we are really trying to operate by are not having any people necessarily in situ at location, minimizing the fixed infrastructure, but using intelligence and autonomy to bring together the ability to harvest materials using energy rather than physical contact. So OffWorld is really developing a new form of mining, which we've coined touchless mining, using our swarm robotic mining architecture that we developed. And from a lunar perspective, we're operating on Earth predominantly at the moment, but from a lunar perspective, we really are at this extraordinary moment of opportunity. With the onset and the promise of heavy reusable launch capability, this is a mind-boggling game changer. Everything we assume, all of the business models that we've kind of, especially us older folks, Madhu and others, we've grown up with a certain mindset and culture of how things are to be done and how things have been done in the last century and the first decade or two of this. But really, it's going to be the young generations. Irene, your leadership and your generation's leadership are going to redefine how we think about going into space and what we do as we move forward. And this is critical. It's absolutely critical that we remove the shackles of our prior assumptions, remove the timidity. Let's not be timid. Let's not be afraid of being as ambitious as we can imagine, because humanity depends on it. We need to mobilize tens to hundreds of trillions of dollars of cislunar and inner space economy before the end of this century, if we're to have a chance to continue the growth curve, the economic development, and the sharing of hope, prosperity, and opportunity for many billions of people on Earth and then beyond. So the responsibility is ours now. I think in celestial business mechanics, the term is called "go for it." Let's just go for it, because there is no alternative. And what is enabled by such a capability? Well, what's enabled is that we can then build large space infrastructures off Earth. We can learn how to really manipulate, manage and harvest minerals, how to process into manufactured goods and systems that are essential. And what is really critical is our ability to build energy generating systems outside of Earth's ecosphere and beam back that energy safely to Earth. And the first footsteps of all of this is building machines that can allow us to do this, and intelligence that allows us to operate. So OffWorld has pioneered the swarm robotic architectures. We have a number of patents and developments and IP around this for many years. And the critical opportunity to have machines built on a modular platform that can operate in these architectures is really the game changer that allows us to move forward as we build. We've deployed several species already terrestrially in terrestrial mines. This is one of our surveyors in a surface copper mine in an open pit. I particularly like this footage because it's kind of lunar landscape already. And personnel are not permitted to walk on this kind of environment post-blast. So in some ways, here we have a safety constraint, but on the lunar surface, we'll have an operational and economic constraint of how much we want astronauts and crew to really be simply operating machinery directly. And when we take this kind of architecture and capability, the beauty of these approaches is that the systems development from a software and digital platform and intelligence layer consideration is very, very similar to what we're going to be operating in space and on the lunar surface. The hardware lessons and the systems lessons are then invaluable. And so when we have this multi-capability first species on the way, we can then undertake an extension of our autonomy capabilities into not only the mobility and sensing and operations, but then into the direct manipulation of rock. And so by being able to establish mastery over ore and mineralogy using selective mining, closed loop sensing, 100% autonomous rock face operations, this ushers in a brand new era of what we can do in swarm robotic mining and architecture. And here you see a third generation excavator in live platinum mines. But But really where we want to go, I mentioned this, the principle of touchless mining, both on the lunar surface and on Earth. Touchless mining involves the embedding of energy directly into the rock phase to weaken the grain boundary bonds, turning hard rock into soft rock, and really allowing us to then start mobilizing forward, reducing the cost of mining here on Earth by 2 orders of magnitude, and setting ourselves up for operations on the Moon. We've already started the development of our Prospector class lunar swarm robotic mining vehicles. This is part of a 3-ton, 3,000 kilogram articulated robotic system in 2 portions. This is basically a multimodal laboratory for ongoing operations on the lunar surface. Our planned launch for the first is 2028, and then a series of several dozen after, beginning in 2030, built on our production lines of identical to our terrestrial robots. And that will enable us to start establishing exploratory and then pilot operations on the lunar surface, testing out different species of robots on our modular platform to embed in then permanently shadowed regions for cryogenic-based operations. And it's particularly critical to undertake extensive operations on Earth to fully test out what we're doing and why we're doing it, so that we understand and reduce the risks to the greatest extent possible of what we then will need to do on the lunar surface and how we expand and scale operations there. We've been, over the last year and a half, we've been working with OffWorld Europe in Luxembourg, has been developing microwave beam applications of our lunar ice water processing module. So we've been developing a microwave architecture to extract water ice from regolith, and making excellent progress on that as we then move into phase 2. And that's where we'll bring together all of these technologies for our first 2028 launch to the lunar surface, and with the rest of our colleagues in the community, spearhead humanity's recovery, expansion, and growth into the solar system. Thank you.
Excellent. Jim, the visuals are very enticing. In the architecture world, in the civil architecture world, there is a saying, and this is only among the trade folks. They don't expose it to the public, and that is the job of the architect is to receive and to deceive the client. And the way we do this is to make our visuals so very attractive that your contractor and your client comes back to you begging for more. And it is very important that in the first phases that you do that. But you've gone beyond that to another area, which is even more interesting. I was reading Harrison Ford, and he told a story about how he was different from the other people in the bus who went to do acting in Hollywood. All of them got in the bus and said, "We are going to go do acting." And many of them got burnt out. And what Harrison Ford did was very interesting. He learned a different trade. He said, "I was going to be a carpenter for the people who do, all the things for sets and so on." Guess what? He survived and survived till the time came to do the real thing, and he was totally prepared. And this is very important for all of us to learn, I think, that, if we get our hands on something that is making a profit for you on planet Earth, it's much easier to step up to the action in the next frontier, Jim. And I think I commend you for these wonderful things that you're doing. Thank you so much. Now, Irene, you have a demo to show us. Is that right?
Yes.
Oh, please do that, and then we'll come back for questions.
Okay. So I will just share the screen. This is just a few minutes about our technology from HiveR. And so let me just share. Okay. So yes, we started with a very basic, without having much insight about rover technology at that time. So we started with basic technology, try to figure out how Rockaboby chassis works. And here we already started to present it to the public very early. So our system was made the way that it could be shared as well. We have very easily changed from into the drive mode. We just put for example, the differential beneath the CubeSat and try to figure out what is more needed. We fastly found out that customers want to have a platform where they can create something which is necessary for them without great limits. That's why we created this 4X drive system, which has all these things which makes it drivable beneath the CubeSat. We created the PCBs. We figured out how much weight it can handle. And we created this one also for Earth. So as you can see, the topper part, you can still move it, you can exchange it. And this is how our technology is being made. So this is the regular face of our rover with the regular drive system. And you can use the empty CubeSat for whatever you want. Here, for example, on a Volcano, they have put a very expensive LiDAR system on the top, a Jetson computer inside to make a mapping of the whole volcano. And you can just also see the outcome of the image, which are very clear. You can even see the shadow of the people down there. And you can also see the precision. So for some cases, you can use it that way. So here, another team was using it to measure the Earth magnetic field, the shift of the field. And here they have redesigned the upper part of the rover. So we just gave them the basics, and they have redesigned it for their use cases. And so here you can see the huge pole, and still our system works very stable and fast. And this is extremely important here, because then they could remotely control it and then let it drive, make precise measurements as they needed. So this is from today. So a few images while the students were using it. And you can see it became very dusty. And yes, so you can see how they remotely are driving it. And this is, for example, the facility, #TheMoon in Rostock-Lager. And I also have added some images from last year, so you can see how it's been done. You can see the QR codes which are placed. The students had to, there are several tasks. They had to scan it. They have to figure out what's going on. And so this was also from last year that we can see how it's been done, because I couldn't cut everything together from this year. And so what we want to present is that actually basically everyone can drive our rovers from all over the world. Last year and this year we had participants from Australia, Indonesia, India, the Emirates, and Korea, China. And it just stopped like America, Brazil, Mexico, Canada, and US, of course. So it went just around the world, and basically everyone was allowed to log into our rover and remotely control them. And yes, to make it possible, we had this great team. And so, yeah, that's basically all. It's, as said, a short video. And I hope you.
I thought I saw Frank in the last bit over there.
Yes.
And this was a question, folks. We're going to spend a little time in discussion about about IMD, about what we saw today, and I'm sure some of you are itching to ask some questions. I do on my part, so maybe I'll give it a quick start here. And the question was for Frank and for Irene. There are many facilities in the U.S. as well now. I think I'm sure in China too, and in Korea. We call them dirty vacuum chambers. And what you do is you simulate with a little higher fidelity than what we saw on the moon simulator that you just showed us. So you would create a vacuum, and then you would do what we call a gravity offloading. That is, you make your vehicle purposely lighter by offloading the mass through a lever, and so you make a 10 kilo or a 5 kilo rover act like it is 2 kilos or 1 kilo, and that changes the traction and several other parameters of a vehicle on a terrain, whether it's on a plain terrain or on a slope. And I think these are all things that will happen in time. Did you have some comments, Irene or Frank?
Yes, for us, for example, it was actually very challenging because on one hand, it has to be a light system for the moon, but it also has to withstand all the forces of the starting condition of a rocket. Yeah. So the thing is to find the right balance of material and behavior of the systems.
Yeah.
So this is still challenging. I think from the mechanical part, we are now going through a lot of iterations, and now we figured out the best way to go. But yes, now there are the other challenges, of course, like thermal and all these things. We are still working. We have great solutions for all these things. But yes, that was very challenging.
Thank you. Frank, did you want to add something? I maybe he's not with us. Okay. Okay, good. I had any thoughts for Jim? I see Jim is still online. Jim, did you have some thoughts?
No, I thought that was the superb results and experience you're generating there, and that's a brilliant service and capability that Neurospace is doing. So, congrats, Irene. Keep that going. Keep building.
Thank you very much.
Okay, folks, if you have some questions for Jim or for Irene or Nasr, please exchange your thoughts. I was hoping the other two would show up, but we have a little time to probably think about the future, and I'm really excited to see Jim. Where is your next demo going to be, or where are you planning to? What are you planning to do besides that very scary looking dragon that you showed in the last image? The multi-tooth dragon.
Well, the real opportunity in the mining world is separating the ions of metal as early as possible from the waste surrounding mineral and rock, as closest to the original rock phase as possible.
At the origin, I see.
At the origin point. Now, just that principle, if we move beyond the 17th century and apply that principle with the tools and the technologies that we have today, bringing together embodied AI, generative learning, deep reinforcement learning, autonomy, robotics, closed-loop sensing, and robust engineering, we can really change the world, and the space industry can lead that change. And so our next developments are really starting to move into full production phase of these robots. It's taken us a long time to get to this stage, but we are now on the road to production engineering and manufacturing to deploy in specific mines around various regions. And that's where I think we're going to show, not immediately, but in due course, a 2 order of magnitude reduction in energy, environmental impact, and cost of mining. Can you imagine what opportunity that liberates? How we can then reimagine the multi-trillion-dollar construction, manufacturing, and materials industry when the core and source materials can be gained so cheaply. What it can do for local communities, what it means to reconfigure the lives of millions of peoples in the global south, where many of these mines are, and how we take those lessons learned in the reconfiguring of those communities and the liberating of opportunity. How does that teach us what we can do moving out and building communities and society in space? I think we have everything to play for. It's extremely exciting.
And who are the heavyweights in your arena, Jim? Do you talk with people like Caterpillar and folks who are involved in heavy mining projects? Are they?
Yes, I mean we talk with many participants. We work with the big mining companies, work with smaller ones, a number of geophysical institutes. In many ways, it's such an integration play. I mean, there are so many facets to all of this. It's really about bringing together best of breed capabilities and architecting solutions that are operationally, geologically, and economically viable.
Some serious geology is involved. You know, when you talk about extracting the minerals exactly where they are, I'm reminded that you have veins of these in the deep structure of the terrain, and once you go down there, you just want to pick the gold. You don't want the rest of the ore.
The more you can, I mean, the grade of many of these minerals and the ores are easily less than 1%.
Interesting.
Absolutely much less than 1%. So traditional conventional mining today involves drilling and blasting all of the ore, a great part of the surrounding waste rock around it, and then moving all of that hundreds of meters or even kilometers to processing plants, and then crushing and milling all of that in several circuits. The energy expenditure is scandalous, and we're using 3% or more of the planet's entire energy consumption is just dedicated to rock crushing. I mean, it's ridiculous, let alone all the transport costs. The majority of mining is still diesel, despite some electrification being undergone. And so in my view, there's good innovation going on in the conventional mining sector, but it's way too slow. And by architecting our space mining and swarm robotic mining principles, I think we can really add value here terrestrially. And it's a very exciting point in time.
Excellent. Good points. And these are the kinds of refinements, and it also boils down to the philosophy of it, Jim. That is, it is a refinement of technologies where you just go for what you want as opposed to brute force, and moving the technology from 19th and 20th century to this new sensitivity, towards nature. And that's wonderful to hear from you. Nasr or Irene, did you have questions or questions for either of you? Glafki, Nasr, if nobody is asking you a question, mine would be, what do you see the prospect for the next year for IMD? Can you turn on your microphone, please?
Thank you. We're hoping that we will grow more. It's been a slow but steady growth, as you can see, every year. But we're hoping that the word spreads and that we can get maybe in social media and get some reactions. One of the major hurdles really is that most of the schools are off around the world around this time of year because of summer break. So
that's why USC did not want to participate, because my students are all on holiday.
Yeah,
and
exactly.
It happens every year. So, yeah.
Yeah.
So, sorry to interrupt, Nasr. I was just going to say, I think the next 36 months are going to be extraordinarily pivotal. And before the end of the decade, International Moon Day is going to be such a huge event. It's going to be a global event. There's going to be so much pivoting around the historic first landings of humans on the moon to this fulcrum point, this pivot point of humanity's opportunity going forward, where the moon is our next stepping stone into the cosmos. And as Starship and other new launch capabilities reduce the cost to low Earth orbit, and the price to low Earth orbit, this is going to liberate many, many new business opportunities and institutional opportunities to the lunar surface. And I think we'll see a binary flip. Now, my prediction for 2030, I've been wrong several orders of magnitude, way more than I've ever been right. But I think directionally, it is correct.
I hope so.
And I think Jim is on to something. And you touched on Starship. I did sit in on a review, and this wonderful engineer, she says, don't worry about ISP, don't worry about payload. Tell us what you want delivered, and we'll take care of it from there on. Because what's happening is there is an upside down flip happening in our own thinking. As Jim said, we are oldies who had taught that, and I think Irene will understand this better too, because Irene said it's got to be light. It doesn't have to be light, dear, because what they're doing is they care for reliability as opposed to just performance from a launch pad point of view. And this is coming along very strong, because the rovers, the design of tools are all dependent on reliability and serviceability.
And I'll summarize that, Madhu, in one sentence. We need to move from the historical mass optimization of spacecraft engineering to the future cost optimization.
Yep, it is true. And it is true, because that is how the new industry is shaping, and it's not a figment of imagination because Elon just down the road from here is minting because he's thinking that way, and the business is flourishing because again it's so simple to go back to the basics and say if you can fly your rocket ship and bring it back, boy, you've already broken the rules of the NASA game, you know. And of course, NASA has other problems, but still, these are happening right before our eyes, and it's wonderful to see this. Any other questions, folks? Before I run down a few more slides, and then we'll call it a day. Is that good? Oh, Jim is back. Okay, let us see. No, you're talking about Jim Caraval. Okay, good. Who else is here? Frank? Okay, good. All right, Glafki, so is there anything else that we have to do before I conclude?
That's all of it. I hope we're done.
Okay, so let me go back to the rest of the few slides I have here, I think. Let me go here. Can you bring up my slides? Let's see. Oh, guess who that is? Huh. Do you see him? Are you able to see him? Yes or no?
Yes.
Oh, this is Big Sim. He's about 23 pounds now, but he's a scaredy cat. And right now, this look is when somebody opens the door. Anyhow, good night.
Well, Madhu, you took my comment of reducing mass optimization a little too seriously there.
I couldn't help this guy, you know. He looks at him and you got to feed him, you know. And he's our Mr. Garfield. Yeah. Let's go back here. Okay, so folks, we have run through a wonderful program here, and oops. Let's go back here. All right. You know, I want to go to this slide one more time. I had one or two more slides that I want to impress you all with. One of which is, you know, in school, we've been trained that that you know it's all okay to think upwards and to think about the cosmos and so on. But I think there are a lot of lessons we forget about looking at planet Earth and the way professions work and behave and solve problems. So I think all of us, particularly in the astronautical engineering field, should look to answers how things get solved on Earth. And I think Jim is on to that because he is doing mining. You know, this is something that comes back to bite us every single time you're trying to solve a upwards looking problem, not understanding how things get done down here on Earth. You know, I was hoping that Carl and Professor Hubers would be here because I know maybe Irene does too, that all of you are dealing with a high rate of information transfer. And I know that Irene is working with high frequency systems, and so is Professor Heinz Hubers. And what that means is that you're moving from the microwave to the optical. And NASA, fortunately, is also on the train and have developed some very impressive systems, starting with the LLCD and the Illuma, LRCD, T-board, and so on. And they're going to demonstrate this in cislunar space in the next Artemis 2 mission. Hopefully, folks like, there are several people working in Germany. I think Irene may know the groups who are working on the free space laser communications, and they're doing extremely well. So why do I say that is coming? Because it's already here for the last 20 years. This is the backbone of human communications. Right now, my voice and these slides are going through someplace using fiber. And so it's kind of a reverse technology development that is happening, this is already a very mature technology. And the Moon Village Association in particular, I think Nasr may know this, and of course, I forgot to mention that Jim is on the board of the MVA. So all of us know that the Moon Village Association has a plan to operate an Earth-looking telescope, and they've been trying to communicate, contact, and be with creative people who can do this for them. And it's very possible when the launch costs come down even further, these things will happen. That is, placing an optical telescope, an Earth-looking optical telescope on the moon. The one other area of interest, Irene, and this goes for Jim too, because Jim is probably more adept at this because he's into mining already. One of the things we are faced with is when you go down deep into mines, communications become a problem, and it has to be done through relays. Jim may like to elaborate on how your robots communicate with each other, Jim. But I think it's
a basic Manit-based mesh network.
Okay, there you go. So
line of sight for high band comms, and then relays for second data.
Yeah, so these are areas where Irene, even very small rovers can act as relays, carrying large bandwidth information. What did you want to say, Irene? You had a comment?
Actually using the rovers themselves as relays, which is also needed here as Earth application. So
yeah,
yes,
absolutely. And these are critical. And one of the things that we'll be presenting to in about an hour at the Lunar Development, it's coming up, is that many of the architectures presented for the moon show surface habitats. And for the last few years, we've been very concerned that that may not be the place to put structures for long because of meteoritic action. And we know this because we have placed some cameras looking towards the moon, particularly, looking from Earth towards the moon, and we've seen several impacts on the lunar surface. So you would not want to place any high-value assets, particularly habitat assets, on the surface. And lo and behold, last week, a paper was published from the University of Trento, and at USC, we've been looking at lava tubes for habitats for some years. And I sent this good professor our archives, and he mentioned he had already gone through them. So I'm glad that we are all starting to think that habitats could find their place in lava tubes. And again, the good professors of U Trento zoomed in on Mare Tranquillitatis, because that is very close to the Apollo landing site. And this could be a very interesting early mission for Artemis. Now, the few things that all of you need to know about the Moon Village Association is that we have annual workshops in beautiful cities. I know that Jim was in Japan a few years ago, and then we had 2 of them in Los Angeles, and then now last year again in Japan. And Nasr, next year, where is the symposium going to be?
Wow, I think that remains to be seen.
Maybe Jim knows?
It's Luxembourg.
In Luxembourg.
Hosted by Luxembourg Space Agency.
That is right. Okay, thank you, Glavki. Yes, I saw that note. So there will be a beautiful symposium for those who wish to learn the latest and most creative ideas are shown there. And all of you need to be looking at the newsletter that the Moon Village Association puts out, which is a very informative document. And of course, as Nasr was saying, the 2024 report will come out soon. This is the 2023 report. It tells you the mechanics of how the Moon Village Association operates, besides all of the wonderful things like the Architecture Committee, the Commerce Committee, and so on do. I wanted to share some slides that come to me through the School of Architecture. Now, Johan Ostrom is a scientist at the Stockholm Resilience Institute that looks at how badly our species is tearing up planet Earth. As Jim mentioned, we can only survive so long in a zero-sum game before we have to open out and head out, and that is already happening. I'm glad to mention that things are happening, and we have to remedy this situation too, which is what Bezos thinks we should do, taking care of planet Earth. Now, a few years ago, I happened to be chairing the International Space University's planetary defense arena, and that is an area where, again, the space community and the Moon Village Association can play a role. We've been talking about this to Giuseppe, and even the dinosaurs agree we have to do something. Look at that. Even the dinosaurs agree we have to do something because they simply did not have the technology that we possess now. And all of this does not fall on deaf ears because the United Nations have what's called the Sustainable Development Goals for 2030. And when you look at all these tiles that are proposed, it is clear that space and energy, space plays a role in every single one of these tiles. And yet, we don't have a spot for space. So there is a movement, a push to get a tile for space. And it's not going to be easy because, as I said, space creeps into every one of these tiles. And it's going to upset if we were proposing, for instance, an 18th tile for space that talked about clean energy, clean air, and clean water, which is what the space station does for us now. I think we have to reshuffle and rebuild those tiles. So some big debates are going on there, and Moon Village Association may play a role because there is a Space Renaissance Institute that is already working on this issue. So space is for all, folks, and As you know, somebody mentioned the Artemis Accords. It's gaining steam. We have several new entries in just the last year. And, what I find a little bit ironic is that how global politics plays in it all. So if you look at all the blue parts of our globe, those are folks who are signatories to the Artemis Accords. And then what about the red? China is up to their own folks, and so I'm thinking it's high time, Nasr, to turn this whole place purple. We want them all to do what you can, and I think the Moon Village Association is playing a wonderful role in this, Nasr, and the International Moon Day in particular is extremely useful when you talk about this discussion. And that is why small little countries like, I think there's the UAE here. Nasr knows this map better than I do because he's a geography and geodesy expert. They're signatories to both. I remember the Indian ambassador, foreign ambassador, was asked something interesting about why does India connect so much with Russia and not with the US? And his answer was very simple. We take all choices. It's not like we're going with one or the other. And also, he said, just look at the map. We have been living with these people for thousands of years. And all of a sudden, you got a big nation, a strong nation, a powerful nation that has an idea for 250 years. Now, who's going to be a friend, And and it's a very puzzling question about how proximity in geography plays a role in how cultures and nationalities behave. So in the Indian philosophy, there are several. I'm sure all of you have tomes and tomes of cultural heritage books that talk about mythologies and philosophies. In the Indian tradition, there is a group of books called the Vedas, and it is distilled into some books called the Upanishads. And one of the principal, and these are books that go like, you got a guidebook, and you got a volume tome, and then you got an elaboration. So you got thousands of books. But anyway, Vasudeva Kudumbakam means the world is one family. And if you ask who said this, we don't know. It's at least 5,000 or 6,000 years old. I think maybe Irene knows these things too, if you've ever dealt in the Sri Lankan region. And guess what? We propose this, and we do this on our ceilings up on the dome of the capital. Is e pluribus unum. There is strength in unity and bringing people together in diversity. And folks, so I'm going to leave you with these beautiful 2024 slides of things happening in China, in Germany, and Nasr. It's been happening, as you mentioned, in Australia, Indonesia, Spain. I had an email from Italy from Maria Perino adding to the events for today. So, folks, with this, I want to thank our sponsor, Lockheed Martin, and thank you, Irene, for hosting this. I saw that you have part-time scientists in the group. I saw that you have other people in the group, but I don't see it in the slides here. Anyhow, I want to thank you all for presenting, and hopefully we will get the folks who did not attend today to share our slides. With that, thank you, Glafki, for guiding us through the events of today. Any other thoughts from any of you?
No. Thank you very much.
2025.
Thank you. Thank you, Nasr. And all of you enjoy the rest of the full moon day. Look up at the skies, guys. The moon is our global ambassador. No, not the United Nations. Nothing can compete with the moon that comes up every night. Thank you so much, all. Till next time, Glaffy. Thank you for helping, Glaffy.
Thank you.
Thank you.
Bye-bye.